live. Okay, we were live over at the TikToks, but that wasn't doing what it needs to do. So we are live here now. We are live right here on Stimulator. Thank you for tuning in. If you're watching on the replay or you're watching live right now, put a comment in the chat so I know you are with me. I'm trying to show my painting in the background here because I worked so hard on that. I don't know if y'all remember, but I remember painting each one of those lines while I was back in San Diego. That was not trivial at all. Okay. Let's see. Let's make sure that we have it going out to the world. I think it's out now to everywhere except maybe Instagram. Yeah, I think Instagram is the last one. Let's go live on there. Shout out to the folks tuning in. Thank you for coming through. I appreciate it. You could be anywhere in the world, but you are right here with Stimulator. So I appreciate you. Thank you. All right, we're going to wait for a few of our folks who I think we're going to come on later, maybe. We'll see. I'm going to leave the comments on so that they can come on. I was fully live over at TikTok. Actually made a new song over at Suno, a song that I'm very excited to be dropping very soon, because it's a song that will clearly be the theme song for this. So I'm very excited about that. Oh, I see you. Hey. More Life, I see you. Come on up. Shout out to More Life. How's it going, man? You're on mute, I think.
Hello, Doc. How are you?
Oh,
I'm fine. Now that side.
Yeah, it's good. How are you over there?
We are great here. Hey, nice to meet you. Nice to meet you, Doc. It's been very long.
It's been too long. God, why is your camera off, huh? What's going on?
Okay, let me.
For those that don't know, More Life is a regular here, okay? He's an original Stimulator student through the original platform that was called Task. This was the Top Flight Arts and Science Conference, and More Life presented some amazing stuff. When was this, More Life? This was 2020 or 2021?
Should be, 2021. Yeah, that's when we linked up. Yeah.
Wow. And so you presented 2021. I remember it was such a big deal because you were so good. Like, you had so many ideas. You were a student at the time. Were you at MSU, right? Midland State University?
Yes, I was in my second year.
Yes, and then you've since graduated. Congratulations. Now you graduated and you were able to present the research that you were working on at MSU at Abercamps as a virtual poster presenter, right?
Yeah. Yes, I did. And now I graduated and I got a good class of a degree, first class.
First class.
And then what?
Wow. What was your degree in? It was a bachelor's in what?
Come again?
What was your degree in? It was a bachelor's of what?
Yeah, it was a Bachelor of Telecommunications Engineering.
Telecommunications and Engineering. And then the research that you presented, that you were working on throughout your 4 years there at Midland State University in Zimbabwe, Gweru, Zimbabwe. What was that research about? Tell us about it.
It was about water resource management system. We analyzed that in Zimbabwe, many councils, they were relying on manual reading of water meters, because the water meters that were installed at our households, they were manual by then.
Right.
Then the research was focusing on designing a prototype of a water meter that transmits data remotely to the city council. And at the city council, there would be a dashboard, where they receive that data. So it was interesting because I was working on the challenge that was existing, and everyone knew it was a very big challenge in the country.
It's a very big challenge, and you are using a very unique solution to address it, a scientific solution to address it. That is the crux of novel research. Like you and your professor came up with this idea, right? What was the reception? Because you presented it at Abercamps. What reception did you get from people? Yeah.
Yeah, they applauded me. They were happy. I think I had an interface with about 3 to 4 reviewers, and they gave the comments on the aspects of the technical viability, the scalability of the products.
Yeah.
Yeah, those ones. I think if you remember when I said we are working further on this when I went to the Research and Innovation Hub.
Yeah.
Yeah, those are some of the comments that we were then looking into,
Nice,
because they,
nice.
yeah, they brought some light. Yeah.
People don't understand. I'm showing here because people don't understand. People, I need to be proud of my students. Okay, people don't understand. This is More Life certificate of participation where he presented at Abercamps in 2022. He presented this research in a virtual poster in 2022. This is Abercamps' annual biomedical research conference for minoritized students. And this was in 2022. He presented this from Zimbabwe. This is research that he did in Gweru, Zimbabwe, at the Midland State University. And he presented it to an international audience. Okay, Abercamps is the largest conference for biomedical students, minoritized students here, honestly, in the world, but it's always held in America at different states. This year in 2022, I think it was, where was it? Anaheim, California. Yeah, it was in California. This year it's going to be in Seattle, Washington. But yeah, More Life presented his research in there. And then after he presented his research, More Life actually graduated. Like you are a graduate. We are speaking to a whole graduate here. Let's see if we can go to the next. Let's show the people an actual graduate. Look at our graduate.
You have these pictures on my Instagram. Yeah.
Yes, yes. You have to be proud. This is amazing. You did it,
Yeah,
man.
we're very proud. I can see.
I'm telling you, it is not easy for folks to graduate with a scientific degree, a STEM
Yeah.
degree. You not only graduated with your STEM degree, but you did it with distinction. Okay, like you have honors, and then you followed up what you did, your research that you had worked on in theory or in actual, hands-on lab, not wet lab, but in hands-on capacity in your actual research lab. You followed that up by presenting it on an international stage. That is impressive. And then spun it out into a company, right? What are you doing these days? Like you're still working on some of this aerospace applications, right? Like tell us a bit more about the newer research that you're working on now.
Okay. Yeah, we received a call from this organization from UK.
Yeah.
It's Energy Saving Trust. Nowadays much of the scientific focus is looking into climate change. Be it engineering, be it geography, be it agriculture, the investors are looking into something related to solve climate issues. So that organization posted a call for proposals that address green energy issues, and their approach was to seek innovations that develop products that use green energy, efficient products that use green energy. It might be a common product, for example, a television, but that television, which is very common, must be developed but working using green energy. A DC must be the source. So that was the approach of their call. So we applied with a lawnmower, a robotic, autonomous lawnmower.
Oh,
We
it's man.
applied, yes, we applied with our proposal. We wrote our document according to their guidelines. We proposed that we would want to develop a autonomous lawnmower that works
Right.
with solar and battery, no fuel. And we're looking to address the challenges faced by people in rural communities where they do not access fuel, even though that fuel is being said to be harmful. They don't
Yeah.
even access it. And if you look at rural schools in Zimbabwe, they use slashes. The kids use slashes to clean up, to maintain their lawn. So those were the cases that we're presenting to say they need this product. It is autonomous, remote controlled, so that they can clear up their backyards. And
No,
we got selected.
that
Then
makes sense.
after
Go
after
ahead.
we got select after we got selected, we were given at first we were given 1,000 to develop a prototype.
Mhm.
Then as a grant, we developed our prototype, we presented it, and yeah, they liked it. And we were taken further to a new program that they then introduced, which was the accelerator program,
Oh,
Efficiency for Access Accelerator program.
okay.
We were selected there. We participated. It was a 6-month program, a training program. It was extensive business training program, that one. We attended those lectures. They were virtual lectures two times per week.
Where was
Now
this?
once per week.
Lectures were hosted where?
Yeah, online.
Yes, but where is the people hosting them online? Where are they located? Where are they based?
Oh, okay. The organization recruited various people, various experts from various countries. We had some professors from India, some from UK, but mainly they were coming from UK.
Mm.
Yeah.
Okay, and so this
So
is UK based
yeah,
grant.
it's a UK based program. Yeah, yeah. They were hosting it from UK. Yeah.
Okay. And so then, when did you win this $4,000? That is a lot of money. Congratulations! When did you win that? Yeah.
We won this in November last year,
Wow.
2025. Yeah. In fact, I can say we won it September last year, but the disbursements began in November. Yeah.
Okay. Well, congratulations. I am so proud that you kept on going. You have not stopped. This is really amazing. You're making me very proud. You have taken the little motivation we gave you as a student. You've kept on going. You're keeping on innovating. You're applying for more things and winning more competitions, more grants. Very soon, who knows where next you'll be. And so I'm very excited for you. I definitely want to make sure that we get you to present even some of the current research that you're doing at this conference again in Abercamps. I know you presented in 2020, but let's see. We also have CJ on the call, other people who are interested in this conference. So CJ is actually also a researcher located in Italy, right? CJ, hello.
Hey, Dr. Mook, how are you?
I'm good. How's it going, CJ?
I'm all right, man. I'm good. I'm doing good. Great to see you again.
Good to see you again, man. Yeah, I was just talking to More Life. More Life might have been frozen now, but fellow Zimbabwean is us.
Yeah.
And More Life actually presented at this conference that I was telling you about.
Mm-hmm.
So I sponsored him in 2022. This is actually his certificate. He was a student at that time at MSU, Midland State University.
You're on mute now. You're muted now.
Am I? Can you hear me? CJ, can you hear me?
Hey, Dr.
Hello.
Mook, you're muted. I can't hear you. I don't know if it is me or
I think it's you because
I,
it's saying
I only see your lips moving.
yeah. I think it's you, CJ.
Don't know if it is me.
Is your volume? Maybe play with your volume. Maybe
Or maybe let me exit and come back in again. I don't know. Yeah.
sounds good. Okay. All right. Let's see if I'm hearing on here. Sounds good. Okay. All right. Oh yeah, no, they can hear me. They can hear me. Okay, so it is you, CJ. Let's see. Let's see who else will come in. Where did Gregory go? We were just seeing you just there. Where did they go? Gregory was right there. Lawrence, where did they go? Oh, there they are. Okay. McGregory, hello. I see you. Can you hear me?
Yes, good day, sir.
Okay, good. Let's talk in 2 seconds. Stay there. I can see you guys in the backstage, okay? And where's Lawrence?
Um, I think he's live on Twitch.
Oh, he's on Twitch. He's live on Twitch. How do I add him on here? I have no idea how to add him on here. Oh, Lawrence. Lawrence, you have to click the StreamYard link and join us on here so we have the conversation on here, okay? All right. And so I'm going to put you guys in the backstage for a second while I finish my conversation with
Um,
More Life and Dr. CJ. Okay. Let's and then we'll get to you next, okay? So actually Gregory and Lawrence are both at the University of Benin in Nigeria. So that is awesome. More Life, you're back. I know the connection had gone static a little bit. It's okay. I was wanting to finish off our conversation here. And so we want to make sure that you can present this year as well over at Abracams. And CJ, I think it's your audio because I can definitely hear on the other platforms. So yeah, let us know when you can hear. Feel free to come back anytime. But yeah, More Life presented his research. This is his poster presentation of participation virtually while he was in Zimbabwe, presented at this conference at Abracams. And the folks that he met over there, the judges who were looking at his poster and as he was talking about his research and the exposure he got there allowed him to propel him to start doing more and more of these competitions, took the feedback, got connected with this other program in the UK, and that's where he recently won this $4,000 grant that he is just telling us about. And so More Life, we want you to come back and present. At some point, I actually want you to present your research in person in America. But obviously you
Yes,
guys visa stuff is difficult, but I would love that.
you tried.
Yeah, but this year, let's try to do you again virtually. Let's try to do it again virtually. I think there's a way we can figure it out in terms of institution, because you have to be part of an institution to present your research. And it's something I think we're figuring out as well with CJ. Because CJ, I think this would be a good competition conference for you to talk about your work. So let's talk a little bit about CJ and say goodbye to More Life. More Life. Definitely connect with CJ as well on the back end later on, also to talk about your experience, but also CJ is a whole doctor now. This is a PhD holder now, and so he has some mentorship. I'm sure that he can also provide. You're both Zimbabweans. I'm sure there's mutual connection and interest here. But the fact that you already had a successful presentation at Abercamps virtually that has translated to multiple different things, I think is awesome. And we want to sponsor you to do it again. So let's definitely stay on the line, listen to how we're going to do it. We'll do it in the same way we'll do it with CJ. And so let's plan it out to make sure we submit. The submission dates for this, you guys, is actually this coming. It's actually this coming September 1st or September 7th, I think is the deadline. So it's called Abercamps, you guys. If you can look it up online. It's the largest international conference for biomedical minoritized students in the world. And so it happens every year at a different state. This year it's going to be in Seattle, Washington, which is actually where I got my PhD at the University of Washington. So I am looking forward to going, and I want to sponsor a bunch of students. And we have a lot of students who are going to go anyway to showcase our research that we've been doing here at Stimulator Games, all of the proteins that people have been making through these hip hop biochemistry stuff. This is a protein right here. This is myoglobin. People might even know about it. Myoglobin, this is the amino acid sequence for myoglobin, starting with the M, the threonine, all the way at the back, all the way down to the C terminus at the very end. And so we're going to present some of this work because our molecules have actually been validated in the lab. We also have students from University of Benin in Nigeria, McGregory, as well as Lawrence, that we'll talk to very soon after this. They will also be presenting at Abercam some of their research that they worked with Stimulator on for the RBX competition that was hosted with Adaptive. We actually got a binder, you guys, through Protein Design for Africa. And so they're actually going to present some of that work that we did together at Abercamps. This is also their first time presenting virtually. So more live. You have a lot of people you need to talk to to share your experience at Abercamps. And in fact, let me just have you say one sentence on what you would say about your experience at Abercamps. What can CJ anticipate? What can Lawrence and McGregory anticipate from your time at Abercamps? Tell us a little bit about that.
Okay, what I can say is that having connected to the international community of researchers makes you realize where you are in terms of the academic performance. Because when you are logged in the backyard, like in Zimbabwe, sometimes you may think that you are doing the best, but when you are then connected, you'd see now that I have to pull up and continue. So I think this is the best environment for you to rate yourself and see where you are in terms of the academic performance. Yeah, that's what I can say.
And just describe a little bit of your beginning, middle, end of because you log in virtually, and then what happens, and then when do you decide to log out? Like, just describe a little bit about the actual presentation of your poster during the virtual conference.
Okay, I remember when you log in, when you get the link, you log in. It's an interface whereby the reviewers, the rooms, they create sort of rooms where the reviewers come into your room and they talk to you and they leave you. They allow other reviewers to come in. So you'll be like someone at a booth, at a presentation stage where you are being visited by reviewers and they leave you there until that session. It may take you 30 to 1 hour, depending on the number of reviewers that may be interested with your research.
Mm-hmm. Okay, all right. I mean, I'm sure people will have questions for you later on. Hopefully, you can stick around in the backstage, and so you can field some of these questions. Also, share your, if you can, in the comments of because we're live everywhere. We're on Facebook, YouTube, Twitch, X, Instagram, and Kick. Pick your favorite. Go in the comments. Share your contact so that people can contact you afterwards, whatever you would like, how you'd like people to contact you, whether it's DM or email, or if you prefer, but maybe don't put your WhatsApp number, but maybe DM or email, whatever your preference is. Put it in the comments so people can reach out later on with questions, especially how to prepare for this poster presentation, what to anticipate in terms of judges' questions. You've already gone through it once. You'll be going through it again, and so we'll make sure that we get you situated, okay?
Yeah, sure, I will do that.
All right, my life. Talk soon. All right, let me switch gears and chat with CJ. Is he still there? CJ, are you still there?
Yeah, I'm still here. Yeah.
Awesome. You can hear us. Okay, perfect. So yeah, CJ, it's been a while since we chatted. Okay, but we chatted very recently, actually. So that's
we did. Yeah,
that is good. So tell us a little bit about your background and how you're connected with Stimulator. Yeah, so, but tell us a little bit about your background.
Yeah. Thank you very much for the platform. So my name is full name Clive Jabangwe. CJ is just the initials. So I would like to classify myself or to identify myself as someone who sits at the intersection of what I call a neuroimmunobiology and pain. So my target disease or the model disease that I've been working on to explore this neuroimmune biology and pain has been osteoarthritis. So this is a huge a problem globally, which sits about over about 500 million people who are affected globally. And that just tells you how much of a problem it is. With billions of dollars that are invested just to help patients who suffer from this disease, be it from looking at prosthetics, treatments, and all those sorts of things that are related to that. So the clinical care of it.
Yeah.
So my work that really established me in this area was, of course, based from my doctoral work, which was a PhD that was sponsored by the Marie Curie Fellowship.
Congratulations!
So, yeah, yeah, thank you.
A recent PhD graduate, you guys, is here
Yeah,
from the Marie Curie Fellowship. That is awesome. Marie
exactly.
Curie, Nobel laureate, first of all,
Yeah, yeah,
but
indeed,
also
indeed.
really
Yeah,
famous scientist, groundbreaking. And now her legacy is passed down through these
exactly.
fellowships. They're very
Years
prestigious.
and generations later, yes.
Yeah.
Yeah.
So, yeah, no, please keep going. Sorry, I disturbed you. Go ahead. Yeah.
So that's all right. So this was actually an exciting opportunity. You can imagine you are in a consortium of more than 13 partners across Europe. So that also means that you can travel also across Europe. That means also opportunities to collaborate, to learn, to interface with different skills from different people in different specializations and the sorts of things like that. And I was based in Portugal, in a small city, not really small that much, but that is Porto, very charming city actually. Yeah. I was at the Institute of Biomedical Engineering, so this was an interestingly multidisciplinary institution.
Okay.
It specializes in biomedical engineering. So my lab was basically tissue engineering as well. Yeah, but we specialized mostly in microphysiological models, or what some people call microfluidics.
Okay.
So yeah, so I was using microfluidics as a model for a disease, osteoarthritis. And the unique thing that had never been done that I did was it is already established that the immune system communicates with the peripheral sensory system, right? But then my question was asking, okay, fine. What about the role of cartilage? What does it do in this whole communication between sensory neurons and the immune system? And I was specifically interested in macrophages. You know,
Mm.
yeah. So macrophages are these specialized white blood cells that are eaters. They are eaters. You know what I mean? So
Yeah.
that's actually what the name means. Yeah, so they eat debris, they eat all these things, like just to help the innate system, to defend the human body. So I was looking at the macrophages, sensory neurons, and cartilage. You see, because during osteoarthritis you have damage to your cartilage, and then there are breakdowns that takes place at the tissue level. So
Yeah.
they come in their
This
attempts
is
to
that
heal the body.
author. This is that
Yeah,
author people talk about, right? When when the joint pain and stuff is because of the cartilage breakdown and wear and tear.
exactly. You
Yeah.
see, so that was whole, like, so it was like an action movie for me. You know what I mean? Like, you get in there, you're trying to find the main actor, you're trying to find the dead guys, and then you're trying
Yeah.
to understand what is really going on. And okay, fine, then what is the solution? So it was an exciting project, yeah. And we actually I actually identified a number of proteins that would be very interesting to really validate, to see
Oh.
if we then move into an animal model, what can we get, and what can they do? Can they be good targets, biomarkers, etc. To help in the treatment of this problem of pain. You know what I mean? Yeah. So
That's
yeah,
awesome.
basically that was it. Yeah, for my PhD. Yeah.
No, that's awesome. That's really impressive. And I think coming away with a PhD with the unique and novel finding is the whole point of, a
Exactly.
philosophy, a doctorate in philosophy, right? Because
Yes.
you're
Yes.
adding
Yeah.
to the body of knowledge. And so it's very impressive that you're able
Indeed.
to
Yeah.
identify unique proteins that are tied within the signal pathway that hopefully in the future, people can drug in that regard. Did you have a chance to present some of this work in a publication or in a poster of some sort?
So the good thing about the Marie Curie is that they organize what are known as doctoral schools,
Mm-hmm.
and you get to present at different conferences. You know what I mean? So I had the opportunity of presenting these things at different conferences, and also at the European Researchers Night. I think the European Researchers Night sort of like has a spill over into the US as well, where you have a similar thing, if I
Oh,
understand very well. I don't know.
okay.
No, you have the public, they come,
Yeah.
you have like your tables, they come and then you explain science to them in the language that they can understand so that they appreciate your work. Because as scientists, our
Mm-hmm.
work is not a secret that we just cover within some lab buildings. We owe everything that we do to the public,
Yep. Yep.
and they need to understand, they need to know, because also the funding, the money, this is
Mhm.
also coming from them, so we have to
Yeah.
benefit them. So that's the whole idea of why it is very important for science communication, like, and also this platform is exactly like what you're doing right now. This platform is science
Mhm.
communication, publications, and it's all part of dissemination, isn't it? And it's
Yeah.
really important. So I had an opportunity of doing something like that, and you can see how people are very interested in understanding science.
Yep.
Yeah.
Yeah.
So
And
yeah,
the mechanisms behind the science, right? Like
exactly.
there's the process and pathways that you're investigating, but how are you doing it? How are you doing the
Yeah.
investigation? People want to know about that. That is opening up a doorway for a whole bunch of things, right? Now, the fact that you have validated this model system in microfluidics as something that could be used in this specific way, other people are going to want to use that model system in a different way, right? Which creates more doors for different science opportunities. So the reason
Yeah.
I was asking about the poster is that maybe you can repurpose the same poster to present at Abercamps. I think that would be a very unique opportunity. And so let me explain a little bit about Abercamps. Abercamps is the annual biomedical research for minoritized students. In America, minoritized meaning basically Black, Latino, or in science, it's really also women in science. It's a big, gap of how many women, Black or Latino folks are scientists. And so there are a lot of these organizations that have formed over the years to really try to encourage and give resources and guidance and mentorship to folks who are interested in sciences or already in science so that they stay in science, because retention is a really big problem in science. A lot of people end up dropping out. It's hard. The stuff we do is hard. They end up not crossing to the finish line. But it's also a good opportunity for networking, because
Yeah.
basically every school in the country has a booth that comes there, and they know that this is where they can get top students who are presenting their research. And so they can get students to go into their grad school programs. They can get students to get into their internship programs. They get students to get into their postdoctoral programs, as well as, actual employment. Companies also go and recruit. I have gone as a recruiter during my time working for Novartis. I've gone to this conference as a recruiter looking for associates that we wanted to recruit. And so it is a great opportunity for networking. Even in previous companies and even current companies actually do go to this conference as well. It's the largest conference of its type, and usually it's like 5,000 students. That's not even counting the actual recruiters and faculty and folks who are there. So it's a great opportunity, even if it's virtually. Are you still in Italy right now, or are you in Portugal? Where are you now?
No, so I've been country hopping, and that's also been like one of the most exciting things about my career.
Yeah.
So like what you just, I've lived in Italy, but I've moved across countries. Now I've got, I think, about 14 plus flags on my back.
Nice.
So
Yeah.
at the moment now I'm in the UK, so I'm in England right
Okay.
now.
Perfect, perfect. So you could actually virtually present from the UK. And so you can
Mhm.
present your poster. If you have your most recent poster showcasing this work, we can get you registered. Don't worry, Stimulator will sponsor you. Your registration is it's essentially $100. We'll get you registered, create an account on Abercamps, and then you will submit an abstract of your research. I mean, you already have quite a great research package. You can present that. Now, the complication is it's usually open for just current students.
Mm-hmm.
And so it's something we'll probably have to find a creative solution around. I think,
Yeah.
Stimulator has actually exhibited at Abercam, so it's recognized as an institution at Abercams, and we are indeed an institution. We are an LLC incorporated actually in 2023. And so I think you could enroll in one of our programs that is starting up very soon. They're all free programs, no tuition. Just enroll, and then we could get you a Stimulator email account and you can register through that. I think that's what we're going to do with you and More Life. I think that's the best way to do that. It's worth a shot. We
Yeah,
don't have
yeah,
a
yeah, yeah.
.edu, so maybe they'll say no because it's not a .edu, it's a .com.
Mm-hmm.
But I think it's worth a try. And if you're accepted, if your abstract is accepted, which we find out, because the deadline to submit, I think, is the 1st of September. And then we find out about acceptance, I think, in October or something like that. And if you get accepted, you can present from UK and you can just log in. What, like More Life was talking about, you can really present from anywhere in the world. But what More Life was talking about, you log in and you meet, you've been like a Zoom room kind of, and then your judges come in.
The breakout rooms and stuff. Yeah.
In the breakout room, exactly. It'll be like the judges will come into your room at the allocated time, and then you get to meet them one-on-one. You get to present your research, talk about your background, and then even in that conversation, you can talk about future possible opportunities, but also you get their emails and contact, and you can move forward. And then because you're registered for the conference, you have access to all the other breakout rooms. So you can jump into Yale University, you can jump into Harvard, you can jump into Merck, you can jump into Pfizer, you can jump into Novartis, you can jump into all the different rooms, talk about yourself, give your resume around. Also, there's a link, I think you can post your resume, and it just is disseminated to all of the exhibitors. So it's a great opportunity to get yourself out there. If you're looking for any kind of opportunities, this is the perfect environment to do that. They are looking for you and you're looking for them, so it's the perfect time. I think for sure, let's do that at least before end of let's try to get it in before September 1st, just because that's the deadline.
We'll talk definitely. Yeah,
We'll chat.
talk.
And we're all enrolling on this call. Everybody, that's the thing that's combining all of us. We're all submitting abstracts. So I've been working with Lawrence and McGregory on research actually that we worked on a competition that was sponsored by Adaptive, and so we have RBX binders that. We have one RBX binder, but we also have these designs that really expressed well, and it's a story that we are basically putting together so we can submit for Abercams. And this will be their first time presenting at Abercams. Very excited. It's the first time also, I think, like we'll have the banner of, so I've gone as an exhibitor. We've never had we had two students present in 2023, but we've never had African students present. Yeah, so this is going to be fun. This is going to be under our banner, as well as Protein Design for Africa, which is the collaboration that we're doing with these two. And we're starting also this whole thing about Protein Design Consortium. So we definitely want your feedback in the future. You are somebody as well who's an African, all right, is interested in these protein complexes, maybe not in the design concept, but definitely from an immunology perspective. And
mechanistically, yeah, definitely. That's exciting stuff. So yeah, we catch up.
Exciting, CJ. All right, thank you so much for coming by. Please definitely
Thanks a lot.
Log on to abercamps.org and make sure to create your account, and then shoot me a message once you do so, and we can move on to the next stage. All right, Lawrence, I see you. I saw McGregor. He kept coming in and out. Is he still around?
It's network.
It's
network.
Okay.
How you doing?
All right. How's it going, Lawrence? Yeah.
It's going well. It's going well.
Yeah, things are going well. We have exciting stuff that's happening. I saw you over at Twitch. I don't know how to get you. If you're at Twitch, I don't know how to get you on here.
Oh.
We might need to try that next time, because Twitch, I need to get my Twitch numbers up. And so if you already have a Twitch account, that's great, because then maybe I could try to do a live on Twitch, which would be good, actually. That would be really good. So we'll try that next time. I saw you have been looking for the de novo minus on everything. That is research right there. Yes, that is great. Okay, now I hear what you're saying, and now you got me excited now because yeah, it looks like I tried to look up what you said me, and it looks like you're right. We might be
Oh
the
no, I'm
very
right. I'm right.
yeah, we
I'm
might
right.
be the
Yeah.
very first Africans to
Yeah.
well, first de novo period in this field, but also then first Africans to have the structure. So we gotta rush on that. We gotta rush on that. So that's good
Yeah.
to know. But we will probably won't make it into the poster just because I don't know. I don't. It will probably take some time because that is the longest period in time. So where are you now on the poster? Which part are you guys stuck at? Yeah.
Okay, so what do you have the first abstract? What do you have the second? Um, the posters we have not started designing them. We just have the pictures. So I'm going to use pictures from stimulator.com/pdfa. So the
Okay.
graph showing that's blue and ours is red, right? That's showing
Mhm.
our ranking. And, yeah, some of those graphs you put there. So I'm going to screenshot those and add to my own. For Mark, he's going to use blast. He's going to take a screenshot of blast with it showing the no sequence similarity. Also, footseek, the structural similarity page on footseek. Yeah. So I think
Yeah, but
that's what
I
I'm
think
going
you need more than just screenshots, Lawrence. We gotta do more than screenshots. We gotta generate some more figures. What is this? No. We want to share a different screen. Let's see. I'm going to share what on PDFA collaboration. Yeah. So this is the graph you're talking about, right? Oh, he's back. Hello, McGregory. How's it going? I think you're on mute. We can't hear you.
Okay. Good day,
Yes.
sir. Can you hear me
Yeah.
now?
Yeah. Those are the graphs. Yeah. Yeah. Scroll. Keep scrolling.
Okay. Oh, this one.
Yeah.
Okay.
This one. Yeah.
Yeah,
Uh,
this
yeah.
will be good for one of the posters, not both. I think it'll be very important for you guys to also have some pictures that you make of your own. Like you want to, what's this? Yeah, do you see? So this is their poster. This is Kamara Ice
Yeah.
and Amma Nicole's poster. So this is what your poster will look like. See how big it is? Um,
Yeah.
and I think we have, yeah, this is Kamara Ice's poster. And this one is Amma Nicole's. And so even this
She just
figure, right?
has two pictures.
Huh?
The second girl she just has two pictures from what I saw.
Yeah. But so you want the flow of it is abstract, right? So first up top is your title. Come up with the two unique titles, one for each of you. We'll have the University of Benin logo on one side. Or actually, I don't know. Maybe you actually just want Protein Design for Africa logo, right? On this side, and then Stimulator on the other side, right?
Yeah. Yes.
Yeah. I don't know if you want University of logo or University of Benin logo. You could have it too somewhere. That would be good to have. But yeah, you have your title there up top, and then you have your names as authors. And then mine will be last, and then you have your affiliations. Protein Design for Africa, University of Benin, Nigeria, Stimulator, LLC. So you have those affiliations. And then the first thing is your abstract, the thing that you just submitted, the thing that we will be graded on based on whether you participate. And then you get into a background. This is where we'll put what you had in the report, right? About RBX as a target. Why is it interesting? That kind of stuff. And then the very next thing would now be the methods. So this is where we talk about the different methods that we used, not only for design, but also for structure prediction and the evaluation and analysis afterwards. And then we'll also talk a little bit about the wet lab component of this, which was self-free base, right? So we start with how you did the protein design, whether it was with Minecraft, and then structure prediction through bolts. The final evaluation was bolts, right, across all models and then the specific metrics that we looked at. I think creating a figure like this would be good. That just shows almost like a flow chart of your process. I think Tamarind Bio has something similar to that you can use as inspiration. You want to show which tools that you used in your pipeline, right? You went from Bindgraph to Bolts to Pymo, something of the sort, right? To pick your final designs. How did you streamline them down? I know I picked the final 3 or whatever, right, from
Yeah.
11, but you can talk about the process until my part, and you know what I did anyway. I just scored everything with bolts, and then submitted top best, right, across each of the different categories. So I think you can also talk about the input. So you did quite a lot of preparing your structure, right, and so talk about the C term versus N term. Talk about a little bit about the design choices there. I think it's a good opportunity to even, shout out some of the tools that you were using and the people who sponsored those. That would be really good. At the very bottom, I think it makes sense to also have another figure that maybe even just describes the platform that you used, right? You used Tamarind Bio. Maybe you can have like a snapshot or something of what that looks like. And that would be good. I would include on both your posters, instead of acknowledgments, you could do acknowledgments, but I would include a paragraph about Protein Design for Africa that just talks about the initiative, why Protein Design for Africa. I think that would be a good paragraph to have at the corner bottom there. I think that would be really good. And you can also acknowledge Stimulator if you want to there, and you can acknowledge University of Benin.
We would.
Yeah, thank you. You can acknowledge Tamarind Bio. You can acknowledge the people who also sponsored stuff. I think Adaptive would be really good to acknowledge there, together with Tudo. That's the section to put those folks in. Up top in results, this is where you'll have that graph that we were talking about. I think this would be a good graph to show. This one is good, but I think also this one is good as well, depending on which poster it is, right? Because I think one poster will have a conversation about all 7, right? And then the other poster is more talking about everything in the competition. Is that how you're structuring it?
Yeah. So my first poster talks about the 3 designs. I don't mention the competition, but that's what Mark's abstract is about. It's talking about the 7 designs and the adaptive bio competition. So I think he's the one that's going to use this. I'm going to use the first one.
Okay. All right. And then I think one section maybe on this side would be good to talk about, like, maybe, because this is a virtual poster, so I think you can put like a little movie at the very bottom here to show the structures, which I think that would be cool, like to show like RBX. So I'm going to try to go into VR right now and show my screen so that you see it in VR, and so we can see what potentially you could show. Okay. Do you remember can you pull up RBX on PDB, like just the RBX PDB, and tell me the PDB code once I go in? Okay.
Okay, 3D QV.
Oh, you remember it already?
3D QV.
3D QD. So I'm going to try to get you guys one of these.
3D QV. Oh, thank you. That's the MetaQuest Pro.
Yes.
Right?
Yes. Hey, wait, but you said 3D QD?
3D QV.
QV.
Yeah.
Yes.
Okay. That's not right. Is that RBX? No, this is the binder, the RBX binder, but I'm talking about just RBX.
3D QV, like we downloaded the PDB 3D QV, then we truncated it because there are other proteins banded to it. We just got the RBX1 protein, so you have to use something like Claude to do that for you. Yes, that's it.
Yeah, this is it.
But we truncated it just to get the RBX1 binder.
But I thought there's a structure of RBX. What did I use? I forget now. This has been a while. RBX doesn't have a structure?
It should because they gave examples of PDB IDs to use during the competition. So just
All right. So this one is RBX. Oh my god. This is annoying. Yeah, this is RBX. And then the structure should be down here. Yeah, so this company called Nanum has a VR software that is basically like Pimo, but in VR. And so that's I'm gonna pull that now, and I'm gonna pull up RBX in VR. If I can just get the structure. What's the structure? Yeah, it's plenty of structures. RBX, plenty. So this is part of the research I'm talking about. You guys should do. Okay, you should have this. Pull it up in Pimo. These are all RBX structures with and without complex of other structures that are available, de novo and not de novo. I think, yes, what's it called is good. Um, Genius or what's it called? ChatGPT or whatever is good for research, but you also have to actually look at the links and like actually confirm, because sometimes these large language models hallucinate. Yeah. So yeah, I think 2LGV is, yeah, that's RBX. 2LGV, I think, is the NMR structure of RBX PDB. I think I remember that from the competition. Which, by the way, if you are watching this on the replay and you want a recap of what the competition was, you can go to Adaptive Bio on their protein base page. You can see the competition is still live there. I'm going to delete this one, delete this one. So we still live? I hope we're still live. I hope that doesn't mean shut down the live. All right. Okay, yeah. Share this tab instead. Here we are. Yep, that's RBX. There is RBX. So we're going to see that in VR. Let's do that. We're going to see that in VR. And then at some point, not today, when we have a better understanding of things, we can also even show your binder in here in VR as well. So I'm going to go in, and then I'm going to need you to read me the PDB code once I get in. No, cancel. Okay, and then let's pull up. Let me share my screen first, I guess. Let's cast so that you guys get what I'm seeing. Oh, cast. Yeah, webcasting next. Horizon.com. Horizon.meta. Yeah, this company, we'll see what they say, but I think they would be interested in sponsoring you guys. Can you go to this website? They have a 3D web. They have a oh shit! I have to pull it up. Actually, I think. I've been talking to the CEO there, and he is very, very kind. Man who's given me a free license for the year to be able to explore this. And so we'll chat. But if you had a headset, can you use it? Is the Wi-Fi good enough?
yes. Yeah,
Okay.
of course. There's the Meta Quest Series S. I'm a big fan of Meta right now. Look up Maluka Beg and stuff. And watch your live events.
Okay. Yeah, LinkedIn. He's on LinkedIn. So which one is? Oh, I'm already here. And then he sent me a message with the link to the, because you can see what I'm doing in the workspace on this website. So you need to just sign up. I would sign up a Protein Design for Africa account, because then we can ask for a license for you guys as well. And then I guess you could do also personal accounts later on, but do the business account first. I'm going to put this in the private chat, okay? Oh, what's in the private? I see somebody already chat. Oh, More Life left his WhatsApp number. Definitely contact More Life. You heard his story, right? Definitely contact him he put his number in the private chat. You see the private chat?
Yeah.
Yeah.
Okay, yeah, definitely contact him. He'll walk you through how to set everything up. All right, now let's remove this and let's share Nano. Because if you go now to that link in the private chat, you will be able to see what I'm seeing. That's what he said would happen. So let's share this tab instead. I think you can now see what I'm seeing. Yeah, you can see it, right?
Yes, I can
Hello?
see it.
Okay, good. Okay. Let's now go into Nanon. Let's, what is it? App Store, I think, at the bottom. No, we can just scroll down, I think, because it's already downloaded. There we go. There's Nanum version 2. Ignore my my apartment. Okay, and then we can jump on in straight into the works. Okay, yeah, this is the workspace we were in before, so you guys can see. I can now actually play. Actually, can we make the screen wider for you? How do we do that? Oh yeah, we can do this, and then we definitely don't want the volume, because then that would be an echo. But yeah, that's much better. You can definitely see it better right now. Yeah, so I'm going to load RBX instead of this protein. So this is the protein, I think, that automatically comes in, or it's the one I was working on before, probably. All right, so we're going to hide this protein. Let's do that. And then, oh my God, I have to remember how to hide things. I think I created a new scene. Oh, this is my thesis protein. Yeah, so Steve and I were in here, and he was able to put my thesis protein on here. So this is the molecule that I worked on in grad school. So this was the first de novo designed all beta jelly roll protein. You can see on the pink, is basically this hairpin that's looped around an invisible barrel. Like you can see it this way, this way, this way, this way, this way. It's a super non-local connection you can get, and it's characterized by these beta arches as the loops, which is actually how we got the cover of the magazine, Nature Structure Bio, because this thing is very thermostable. It does not melt up to 95 degrees Celsius and more. It does not melt. And so it's kind of reminiscent of the beta arches in Utah, the great arches in Utah. And so that's what we got on the cover of Nature Structure Bio, which is super cool. I thought it was super cool. But okay, we're going to try to download now. Let's try to download RBX. Let's see. What was the number for RBX? I need to create a new scene. Let's create a new scene. Lawrence McGregor, are you still there?
Yeah. Yes.
Oh.
Yes.
I don't know how to create a new scene, though. You showed me this, and I now forget. If I go there, that one is done that. So what if I spotlight me? And then what? Then I create a new scene. How do I do that? How do I create this? Huh? Okay, so what? 2L what?
GV.
GV. If we search that, no, it's not coming up. Oh no. My name. Let's see what else. What else? No, this is out. This is. Oh, okay. Hey Mara, can you pull up PDB 2LGV? So there's an assistant in here. Let's see if that helps because chat, I can't figure it out. 2LVG is not currently loaded in the workspace. Load import first and I can create views. How do I load import? Teach me how to load import. Okay. Load and import PDB 2LGV. I can adjust molecular scene components, but loading, importing a new PDB to 2VG from here is not possible. Okay, we're in the workspace. So how do I do that, though? I don't know how to do that. Okay, this is why I should have played around more with it. This is my fault. All right, let's go into the workspace. Okay, and then enter code right there. There we go. Okay, so 2LGV. I love that it's very intuitive though. At least something. Let's see. Is it coming up? Did I get it? Resume. Oh no, that's not the right code. That's the code to the workspace. I need a code to. This is just the workspace. This is to use workspace. So if I load that. Okay, but I want to now.
Can you talk about your post on the more about? I would like to know more about the beta sheets person.
Oh, this one?
Yeah. Does it bind to anything or is it just completely de novo?
It's completely de novo. It doesn't bind to anything. The purpose of this was to prove that we can make, first of all, something like this using Rosetta methods and to learn how these proteins actually are made in nature. Learn about folding, learn about, how do you make something so thermostable as well. And then also just make principles for future designers, right? So we made principles as rules that govern design. For instance, in green are all the hydrophobic residues that make up the core of this protein, which is why it's so stable. It's like a rock essentially because it's packed all throughout. There's no hole in between. There are no cavities in between. Whereas a ligand binding protein or an enzyme or something would have such a huge cavity here where water is accessible. This does not. And so what that means is essentially you have what's called this hydrogen bonding caging thing that happens where basically hydrogen bonds form around the molecule, pushing all the hydrophobic residues together. These start associating with van der Waals forces, and they basically make a tight, packed core. Externally, you're seeing all the moieties that are polar interactions, right? So you see your aspartates, your arginines, your lysines, they're all on the surface. And so they are interacting with water molecules all across there. One thing with beta sheet type proteins that we have to make sure of is that we don't have, what is that? Oh, did McGregor fall out and then come back? Let me see if I can get him back in. I think that's what the noise is, right? I think that's him. Yep, it's him. Yep, let's put him back in. More life. What are you? I see you're still here. What do you think about this as well? Oh, some comments in the chat. What comments do we have? What is this? AI viewers. Okay, we have garbage. Okay, if you go to this link right here, you can actually see what I'm doing from the 2D interface on your computer. You can actually see the workspace in your on your computer. If you go to this link right here. Oh, not this link. The link in the private chat. Sorry, I can't actually put it on the private chat. This link is to the molecule that we are trying to pull up, the 2L VG molecule. Let's try to do that. All right. One other thing I like about VR is I could, if I wanted to, I could pull up the actual paper of this molecule that we were just talking about. Let's see, can we put it over? Let's close that. Let's close that.
So, did you create new softwares for it, or it's RF diffusion? And what are the applications of it?
Sorry?
I said, did you create a new software to create these beta sheet type proteins, or is it RF diffusion used?
Oh,
And
no, this was Rosetta. So this is
it's not AI based.
It's not AI based. This one is biophysical based. So Rosetta, is the beginning of all of this protein design. Well, I mean, there were others before, but Rosetta definitely is the one that made the mark on this. And so Rosetta does not use AI based methods. I mean, of course, Rosetta Fold now does, and the R in RF diffusion stands for Rosetta. I think Rosetta Fold diffusion, I think it's called. And so Rosetta really is the parent of all of this stuff, but it's based on first principles, biophysics-based metrics that correlate to computational metrics. That's what it's based on. Okay, I'm going to try PDB, PDB, enter. Yay! Okay, comes right up. Let's see. Can you see that? Oh, okay. McGregor is back. Hello, McGregor. Are we there? Oh, add to stage. Okay. Add what we are seeing here. You guys can see. So yeah, there we go. That's the structure, but you can even see the publication associated with the structure right here. That's me and my mentor, Eric. Enrique Marcos, shout out to him and all our collaborators, as well as our mentor, David Baker, together. And so if you go to PubMed, you can search this guy right here. This is our paper. But also you can, I wonder if you can pull up the cover. Can you do that? Because I think it could be. Yeah, because there was an article about it, several actually during the time. Usually when I look at Google, it usually shows me that. But I guess because we looked at just the PDB. Using your. Yeah.
How many years did it take you to develop that or do your PhD on that?
Days.
Sorry, how long? Sorry. How many years? I said how many years did it take you?
Yeah. No, so my PhD was from 2014, and then I graduated 2019, so 5 years. But I didn't start working on this. I didn't start working on this until probably 2017 or 2018. Yeah, 2017, I think, is when I started working on jelly rolls.
So it took you 2 years to get the structure. Wow.
Well, to get new, because these are all de novo, by the way. So this sequence does not exist in nature. Maybe now it exists. I wonder if anybody's using it now. That is actually very interesting. I wonder if anybody's using the sequence. Well, that's a separate question. I wanted to show this goddamn cover. Why can't I show this? Where would I go
So
for
I
this?
guess we are the new generation of protein designers because we are using AI like our after Rosetta like so this new AI models. So so you were using the physics based models, right? Like Rosetta.
Exactly. Exactly.
So
When,
those were slower.
huh?
Were they slower? Like was Rosetta slower compared to what we have now?
Yes, yes. So Rosetta, the process was slower. Very much the tools, were, I mean, similar pace in terms of you have to submit several jobs and then, do filtering on your jobs and all this kind of stuff. Similar process, similar speeds, but the number of loop or cycles that you had to do was just much larger than we do now with AI based methods. So first you had to figure out what is the backbone. You had to enumerate exactly the backbone that you're looking for, right? So this, oh, we have to go back into Nanome because we're not in Nanome anymore. This this structure that you're seeing, includes the sequence, right, and the sidechain residues. But what underpins it, the very basis of it, is how the carbon alpha connection is all throughout, right? So NCC, right? NCC is like how each amino acid is linked by the peptide bonds to the next amino acid to the next amino acid, and how that carbon alpha relates to its closest, nearest carbon alphas all around it. That is the backbone of this protein molecule, right? And so that peptide bond all across dipeptide, tripeptide, 7 to 8 peptide. This is 7 to 8 residues. And then how that polypeptide assembles to form this jelly roll motif is also part of that backbone motif. So you have to make several combinations of this, right? Where this is a strand, and then you have a loop, and then you have a strand, and then you have a loop. So you have to enumerate different combinations. So this strand maybe is 5 residues, and then the loop is 2 residues. You want another one that is 4 residues in the strand and 3 loops, and then you want the 5 strand with the 2 loops, and so forth and so forth. And you do that for every single strand, every single loop. Then we used what's called fragment assembly. Blueprint Builder, I think, was the protocol that it's called, where you're basically taking short peptide chains or little 3-mers and 9-mers, and you are basically stitching them together to assemble multiple of these different backbones. It's coming from a library of these fragments. I think the Okazaki fragments, something like that is what it was called. And so you're making multiple backbones with that fragment library, and then you're scoring those fragments based on Rosetta energy and a heuristic for delta G of folding. So then you're pruning that, and then finally now you have a set of backbones. Now you want to basically now add sequence to your rotamers, right? You want to make sure your rotamers are actually in the right conformation, that is the lowest energy possible, which would correspond to a sequence that would potentially fold to that. After that, we used to do something called forward folding funding, which was a lot of hand wavy, but we did it, and it kind of corresponded to some semblance of success. And in fact, if you open this paper, you probably will see some of that stuff in here. Now I don't know if we can open it because I don't know if I have. Oh yeah, I do. Okay, yeah. So yeah, you see, so this is the backbone enumeration that we were talking about. You can actually see that in this. Oh wow, this is so cool. You can actually see that in here. So I have the protein in Pymol right here in pink, and then you can see the elements that we were just talking about. Can you hear me, Lawrence?
I can hear.
Yeah. You can see the elements we're talking about. So this topology has what's called these beta arches. Also, I was saying I was looking for the cover so I can show you the cover off the paper, but anyway, it's on a different day. And if I do a clip, I'll stitch the cover right here. I'll put it right here for you guys. But yeah, these motifs, this beta arch, are characteristic of a lot of beta sheet type proteins. How the beta sheet sandwich basically forms is by having that sandwich together with the hydrophobics in green together. What forms the interlocking sandwich on either side are either hairpins, or because it's non-contiguous paired strands, it's these beta arch loops. And then when there are two beta arch loops together, they associate to form a beta arcade. And then this is a solo beta arch on this side. So here in this figure, describing these motifs from native jelly rolls, what they look like, and describing basically the phi-psi angles that are represented in the Ramachandran plot across the different 5 mers, 9 mers that you would find with this specific motif. And so that was part of defining this motif, right? Is okay, if we are starting from that space, let's look at what nature has done and then see if we can develop rules to generalize across the topology so we can make our own brand new jelly rolls. And so here you actually see those beta arcades that I was talking about, enumerated and forming, and then down to the literal mathematics of it, like it's a specific angle that actually forms this, and that angle that can be translated to a vector in coding space, right? And that vector mathematically can be enumerated across multiple different combinations combinatorially to make multiple backbones. Those backbones, we then, this is the forward folding funnel I was talking about. We do a sequence optimization. I think here we were still using fast design, which included layer design, I think, which basically highlighted, okay, surface residues need to be polar, core residues need to be hydrophobic, and then you had some boundary residues that are a mixture of each one. And you were scoring based, again, on Rosetta energy. You stick for delta G of folding, and so that's what you have on the y-axis. X-axis is RMSD, which is basically your structures here in green sampled, and then all the 20,000 plus simulations that you have done of the fragment assembly sort of ranked by RMSD and Rosetta fold of energy. And a successful funnel, which is what we call the forward folding funnel, is one that pointed downwards like this. You had some simulations that approached in RMSD, so that means they were very close in resembling your designs, but you also had some that were low in energy, because you see majority of these are high energy structures, which means they are likely not going to fold into the sequence, is likely not going to fold into this conformation. But some of these low energy structures, likely the sequence is predicted to fold into the actual structure. And now because it's close in RMSD to your designs, it's actually the structure that you have designed for. The first graph here is something called circular diacharism. We're actually going to do this for our protein, you guys. So this is an experimental characterization. I did this. This is my plot. Actually, this is my graph that I'm showing here. And so circular diacharism essentially measures what's called elicity, whatever. So this is like the chiralness of your protein, right? And so essentially it describes secondary structure elements of your protein. So a beta sheet type protein will have a specific signature that's different from a helix type protein, that's different from a random coil protein. And so because you can separate the difference between a random coil protein and a helix or beta sheet protein, that means you can separate between folded and unfolded. And so if you raise the temperature from 5 degrees all the way up to 95 degrees Celsius, you can monitor how your protein is changing shape as a result of heating up or changing the temperature, right? Which then basically is your unfolding transition. And the well-folded protein is typically characterized with a sigmoidal curve in a TM. Now, the thing that you might see here is that at 25 degrees Celsius, which is in green, it's the same as 95 degrees Celsius, that is in red, and it's the same as 25 degrees Celsius back again after it has gone up to 95 degrees, which is the other color blue. And they're all basically overlapping with each other because this guy does not melt. It doesn't unfold up to, at least not at 95 degrees Celsius. So it's a really thermostable, rock stable protein, which also is a character for a lot of de novo proteins. What we showed here was an HSQC. So, NMR is a whole other different way to characterize proteins, gives you the dynamic solution characterization of proteins NMR actually tells you basically how your proteins in solution are behaving, but it also gives you a signature because every amino acid and every motif has a specific spectra associated with it. And so the HSQC showed sort of like the H parts per million, on the x-axis, and then the nitrogen, so hydrogen versus nitrogen, 15 labeled, right? So this is isotope labeled protein, and so you're showing that on the y-axis and x-axis on the side. And so a well-folded protein is one that typically has dispersed peaks, so the peaks are really far apart with each other, whereas a unfolding or molten globulin protein is one that those peaks will be super tight. And so it was a great check of how folded our protein was. We were also attempting to get a structure of the protein through NMR methods as a 3D characterization, and that's exactly what our collaborators were able to do. These were collaborators in Canada. Actually, they were able to get this final structure. And you can see as enumerated by, those hydrophobic interactions that we were talking about in Nanum, you can even see them sort of like here in that structure in Nanum. You can see them highlighted here in these figures here, that our design model matched perfectly with the actual structure. I think this was like 1 RMST, one angstrom, I think, and then like the deviation between the structure versus our design was that less than 2, I think. It was spot on. It was pretty great. It was really
cool. Really cool. So if for our RBX one, right, if we're able to get external structure of it, will it be nature worthy? Do you think?
I think so. And after what you found today, I think so. Because you found basically that there is no structure of a de novo protein of RBX. So I think that is interesting. I think in itself that is interesting. And then the fact that it's the first structure, de novo structure to come from Africans, I think that is worthy as well. Like, so I think it'll be worth.
All Africans.
Huh?
I say all Africans.
Right.
Three of
right.
us.
I think it'll be worth doing for sure, and hopefully we get it. It's tricky, RBX is really tricky to get protein off, which is why I wanted to pull it up, because it's mostly unstructured, so it's difficult. Come on, Nano, this needs to be straightforward.
Also, we talked about Innovate Africa. We talked about also working on something together.
Oh, the climate change, yes.
Yeah, it's on agriculture.
Yeah. So when is the deadline?
August 31st.
Also end of the month. Yeah. Do you guys have any ideas?
Yeah. No, but I can brainstorm to you after the live stream. Because get some ideas. Possibly.
You should. Yeah, I have some ideas on bioremediation. So another structure I worked on, basically, you were asking because this one doesn't do anything. The other one has a loop on this side that actually binds to calcium. And so I was thinking of using similar methods to then use it to bind to lithium. And this is where more life you might be interested in, because this is where our disciplines intersect. Because if we're able to bind to lithium, then we could purify more in an eco-friendly way, in a climate change friendly way. We can purify battery waste, which is it's a huge problem in electrical engineering circles that more life focuses on. It's also a nice way to concentrate lithium. So
I love that one.
Huh?
I said I love that one. The Innovate Africa. I think I once read something about it.
Yeah. Did you have something to pitch for there?
Yeah, if there's opportunity, because that area, Doc, I think it's worth paying attention. The side of climate change, green energy. There's that opportunity, I think.
I agree. That's where a lot of money is. That's one of the reasons I sent this to Lawrence and McGregory, because I think a collaboration between protein design and then engineers like More Life, I think it would be such a stellar. Oh my gosh, that would be such a tight submission and entry to this, because you're really approaching it from
Yeah.
both angles, right? The mechanic and physics based, angle. Like, basically, More Life is an electrician, but he's like a research type electrician. He can make a.
Yes.
He was just talking about making a whole robot, a whole AI bot, a lawnmower that is automated just now, right? Now imagine combining that with a really specialized protein molecule that only recognizes a specific signal, right? Combine those two things together, you could really have the synergy of a prototype that could potentially be ready by the end of next year, and could be even shelf ready in a few years, time, because that's the other thing. Protein Design for Africa, you guys are so focused on healthcare and therapeutics, which is, I get it.
Agriculture.
That's where most people are focused on in protein design. But the problem is, with clinical trials and regulations and stuff, things take so long for it to become even profitable, to become even, see the light of day. Whereas in climate change, in bioremediation, in even agriculture, indeed, there is much less pushback in that area. There's much less red tape that needs to be handled. So your thing can go from protein design to in-hand product being sold on Amazon in a very, very short amount of time. And so I think the four of us should work on this. What do you guys think?
Okay, yeah. When I looked at it yesterday, they really focused on farmers, on stuff related to agriculture, and how we can help African farmers, maybe get more yield. That was mainly their focus. So that's what they are going to mainly focus on solving. So if you have an idea on agriculture, that's something that's more of like maybe a protein that's kind of maybe a pesticide. I don't know, a protein that fights that can kill a disease, a plant disease. I don't know, but it has to kind of relate to agriculture and should to help farmers.
Yes. I have something. Maybe if you allow me to say it, I have something that I think, Doc, I once sent you on WhatsApp.
Uh-huh. Say it again. Remind me what it was.
I talked about our application to Youth for Climate.
Uh-huh.
Yeah, when we proposed about building resilient households to
Okay.
tackle poverty and droughts caused by climate change. So
How
we developed sort of a model, what we call a sustainable household model, in which we intend to implement features that can withstand the harsh conditions of climate change. For example, we looked at the food generation. We said, since the communities have been relying on rainfall, what if we design a model in which at every household they can constantly produce food using systems like water from the bore, solar systems, the interconnection between fishy, piggery, poultry. Yeah, it was more of a model, and also we included things like biogas for cooking to lower carbon emission. I don't know, what do you think about that? It's something that we just proposed to Youth for Climate.
I like what is the product there? That's the problem. I like the idea in general, in concept, but what are you selling? What is the product?
Okay, in this case, I think the product is the model itself on how to integrate these sections because we are looking to find an approach in which every agricultural aspect that any community can do or is already doing, but can be designed in a way that an output from one end is an input for another. You get a waste from one side is also an input for another.
No,
It's sort of
I get it. Yeah, I get it. And it's a model that describes, the sustainability pattern for essentially being able to tie pig waste to agricultural manure to the fertilizer, and therefore you're able to get a higher yield. Maybe even tie aquaporation to that, where again the feed and stuff that you're getting ties into a fishery, and so then you get more fish coming out of there because it's a circular system. Yes, I've seen it proposed several times. The problem is, to me, there is no prototype. Yes, you can propose the
yes.
model, but there's nothing you can physically, tangibly sell out at the end of the day, which ends up just being an exercise on like what, just these things are difficult because it just ends up being like, okay, I guess we made a website to teach people, but there's nothing we can give. Did I not send this climate change thing to you, Lawrence? Who did I send it to?
Yeah, you sent it to me.
Did I send it to just you, or maybe I sent it in a group? Maybe that's why I can't find, because I can't find it.
You sent me on Instagram. I think it's on Instagram, but I sent you a link. I think I sent you a link to it.
Oh, there we go. Here we go. Call for applications. Yes, this one. So this is what we're talking about, guys. Innovate Africa Challenge. Yeah, we need to submit. The 4 of us need to submit something here. Now,
look for the link on my WhatsApp. Look for the link on WhatsApp. It will take you to the website.
Yeah, I think this is the link right here. It's right here. Details.
Click to it on. Does it take to the website?
Yeah, it's Instagram, so it's not clickable. You have to go to their here. To their link in bio, and then there's the Google Center Community AI Fellowship. Follow. What is it called? It's called.
I think we should design an enzyme, a protein or enzyme that has an agricultural application. So it will be easier for us to get to design 100 proteins, send them the CSV file. We don't need web lab validation. If we win it or if they like our idea, that's when we can do web validation for it. What do you think?
And you guys have very different problems. More Life doesn't have a prototype, which is a problem in itself. But you, Lawrence, your idea is great in that it has the prototype in terms of the protein, but it's not tied to anything physical. Because just ending in simulations, that is not a worthy winning competition, And even if you do the wet lab validation, just the protein alone is just not enough. You have to tie it to some sort of machine that is actually going to then do the work. And so, yeah. So I think there's a middle ground there that we can find. We just have to talk to each other more and work on it. Let's see if I can find the link that you're talking about on WhatsApp. Let's see, can I find it on WhatsApp?
Oh, I think check PDF Steam group or my chats.
Yeah, let me try to do. Oh, you put it in the chat?
Yeah, either PDF Steam. If it's not there, it should be on my our personal chats on WhatsApp.
Yeah. So McGregor, the live is recorded. Don't worry, it's okay. I know internet connections. It's okay. It's fine. And actually, very soon we're gonna have to go because we have Ben on the line. I need to talk to Ben as well. I think he's now free from church now. I think. Hey Ben, how's it going? Oh, and then he jumped off. Okay. All right. Well, Lawrence, if you can put it in. Oh, McGregor put it in the private chat. Perfect. Okay, because then McGregor, you can just watch the live if you want. You don't have to. You can just watch the live and comment and stuff, and you can submit your comments that way. I want to put this in the. Let me put this in the. How do I do that? Where would I go to put this? Where would I go if I give it to myself on Instagram? Can you click Instagram links in the messages? I don't know if you can do that. I don't know if you can do that. Can you click that? Oh yeah, maybe you can click that. Yeah. All right. So I sent that to myself. Let's go back to Instagram. Where is Instagram? I guess Ben logged on and then logged off. What happened to him? If you're hearing us, Ben, say hello. Unmute your mic and say hello. Oh, there we go. There we go. It's opening up. So now, let's see. So, more live. Make sure to take a look at this. The application is in the link is in the private chat. Make sure to take a look at this. Okay.
Hello.
Hello. How you doing?
I'm doing good, brother. How you doing?
Good to have you on board. Okay, we are talking. It's a bunch of Africans on the call today. Okay, it's a whole lot of African stuff right here. We're talking about.
That's where everything is in Africa, my brother.
Okay, that's the biggest opportunity for growth. Honestly, I believe that Africa is our biggest opportunity for growth.
I was listening into the conversations. I didn't want to comment. I just wanted to listen.
Yeah. Oh, this is tied to food insecurity. So that's what you're talking about, agriculture. Oh, I see. Limited access to timely agriculture information, low adoption of digital technologies, fragmented agricultural data systems and skills gap, persistent inequalities affecting smallholder farmers and the rural communities. I actually have an idea, More Life and Lawrence, for us to submit this. And I think, Ben, actually, you could help move forward this on the business angle of this. I don't know if I want to say it here because we are literally live. But it's an idea that I don't know if you guys know this, but I actually pitched an idea when I was I don't even know if you can scroll back that far because this is a long time ago. Can I even scroll back that far? I wonder if I go to my other account. Do I follow this account? Because then, then you can see it there. Okay, there we go. Yeah. This is my Finsta. No, don't bother adding me. I will not add you back. But this is my personal account. Actually, this is me in Zimbabwe with Francophile. Actually, very recently I was in. Well, not recently, but when I was in Zimbabwe last. This is when this picture was taken. That's so funny. I need to show you. So I pitched an idea at a pitch competition, and I won $10,000. For this idea that we never did anything with. It was just pitching it to get money.
Wow.
That was it. Because the competition was just about ideas. It was just, do you have an idea that would be a good startup idea? And I pitched and I won so much money because it was the 10,000 was the finale. But I started off at $100. I won $100. Oh, this is where I actually met Ben. Is this when we met? We met in 2020 or 2021?
It's 2020.
2020, right? So you are in this this task. We did this competition, this conference. So you might be in here. Your picture might be in here somewhere. That is so funny. Oh my gosh.
I might be there somewhere.
Yeah, you were one of the competitors. Some really good competitors we had, including Ben. So yeah, you have to scroll all the way back to a different life that I had. That's also why it's separate from everything else. Oh, maybe your poster is here, Ben. Maybe your poster.
It should be. Is that the one, Truman one? Yeah, it should be one of them.
Oh yeah, we had a rapper Tendai Nguni promote for us. That was so awesome. It was in newspapers all over the country. That was so awesome. So great. Okay. Anyway, all right. And then it can't be that far. Oh yeah, I guess because I graduated 2019, so it is pretty far back. Yeah, here we go. So I won 5,000 for one climate change company, and another 5,000 for third place overall in the whole thing. And it was awesome. It was really awesome. I think that's a throwback picture actually. When I did win, I think it's actually back in 2018. I think that's when I won. Oh, I don't remember. But the idea was the same. It was called Chibage Chip idea. Oh, that's in Hawaii, presenting a conference. Oh, Abercams is somewhere here. I presented Abercams around this time too, because I went back as a recruiter as well. My God, this is why this Instagram is now private, because too much.
There's so much stuff.
Huh?
There's so much stuff.
It is like it goes back to before I graduated. The time I went to Trinidad and Tobago, time David Baker did a TEDx talk. This was so cool. I remember that. This is so way back. My parents came for my graduation. This will be you very soon, Lawrence and McGregor. My family came for graduation, and it was all of this. It was a big deal. Oh, we were so happy. See, this is all of it. Oh my gosh, what's a special time. This is my baby, one of my best friends. Nanette. Shout out to her. Yeah. Oh my gosh, yeah, and everybody, the family, Francisca, Amanda, Audrey. Yep. And this was an amazing time. Oh my gosh. Yeah. So before this, because I actually ended up using the 10,000 to sponsor this trip. This is how I sponsored my family coming to America. This was my dissertation. Yeah. This is my topic. Structural insights from beta sandwich proteins inform the design of de novo hemoglobin domains towards new age antibodies. Oh, actually, oh my God, where is that? When I got actually, because I gave is it here? Is this a video? Yeah. I gave the keynote. I gave the keynote talk for the students, but when I got my actual my gut. Can you hear this? Tell me if you can hear this. Can you hear? Lawrence, can you hear?
No.
You can't hear anything.
I can hear you, but I can't hear the video.
Oh, you can't hear the video. Okay. Oh, actually, I could do this. Oh. Yeah, I could do this. I remember this guy. Okay, now I have to mute myself. How do I mute?
So the idea, are we talking about it now or later? Afro STEM?
Yes. Give me a second.
Next we have Tanuka Martin Fortine Chigyasiku, a member of the David Baker Lab, who's graduating with a PhD in biochemistry and biological physics, structure, and design. Again, he will be hooded by Dr. Jorge Salas, his double header today. He seeks the title of Structural Insights from Beta Sandwich Proteins, inform the design of de novo immunoglobulin domains for new age
What a memory. That's a great time. Anyway, all right. Sorry. I got distracted. Sorry. This is just a great memory during this time. Sorry, I got distracted because the idea is in here, and so I just want to scroll to it so we can read it. Because there's this university that has acted on this idea actually at Duke University. I saw they published something similar. But I don't think they've commercialized on it. And even if they did, I don't know. Yeah, so this is the idea right here. And this publication is up somewhere, so I can send it to you. It's called Shibage Chip. So this combines More Life strength as well as protein design for Africa strength. Is More Life still on the call? Oh, they're in the back. I can add him to the stage. There we go. Okay, so now you're on the stage. So you're
Yes,
on the.
I'm here. I can hear you clearly.
Okay, perfect. Yes, yeah. I had to add you on the stage because I think you might have dropped down, and then when you drop down, you get back in the backstage. Unfortunately, when you come back in, so I have to add you back.
Yeah, network
Okay,
is acting up.
it's okay.
Network.
Yeah, it's okay. So this idea, I think, combines both protein design elements from protein design for Africa towards agriculture, and then it also combines the biophysical, electrical elements from More Life and his company. This Chibage chip is a physical chip. That's what the idea. It's a physical chip. Think of a microchip that goes into plants. My whole shtick. So this was together with Carla and Thelma and David Baker and the whole Ian Hayden. And so this idea that I came up with was basically a pregnancy stick for plants. You can even see the phrase in here. So because plants in conditions, right? We were just talking about it. How do you? So yeah, this is a prototype basically. How do you save? Not save, but how do you deal with climate change? How do farmers deal with climate change? How do you give them a tool so that they could deal with climate change in this era? And I made a poster here. I wonder if I could zoom in so you can just see the idea. Yep. Oh wow. Oh, I love that. Yeah, and so the Baker Lab actually paid for all of that for me to do the exhibit there. And then if I could just, yeah, I can zoom into that picture right there. Can you see that? You can't see anything. You can't see anything. Yeah, Chibage. Chibage is Shona, which is the language that I speak to in Zimbabwe. It means maize, and maize is one of the most popular agricultural crops, right? And Chibage chip, basically the idea was you would have this chip that looks like, oh, where did it go? Oh no, where did it go? Oh no, where did it go? Oh, I can't start again. Oh no, that's too far back. I can't scroll back that far. Okay, I'm gonna have to send it to you guys later. But the idea was this, right? Because I can't go all the way back again. That took way too long.
It's very far.
It's because it was in 2018, so it's been a while since then. But the idea, anyway, is that imagine a sensor, right? In your words, in your world, More Life. Imagine a sensor, right? A chip sensor, right? A biosensor that can detect an electrical signal in plants. That electrical signal is mediated by a protein that is able to detect a specific chemical or hormone that is only secreted in plants when they are in a drought situation. So when they are stressed by abiotic conditions, right? Whether it's heat or thirst, essentially, like lack of water, that kind of stuff. And turns out there actually is a plant hormone. Like this is the stuff that is not all the way validated, but there's this publication I found from Duke University that we can build upon. Because it seems like they've done some stuff that was very similar to what I had in my mind, even though I spoke to some plant biologists who were like, yeah, I don't know if that's possible, but other people think it's possible. Anyway, so there is a hormone that plants do secrete when they are thirsty. So it's considered a drought resistant hormone. So when many people have been looking into engineering crops that basically have a lot of this hormone, so that it shows up in the xylem or phloem or whatever in the system, the central system of the plant, so that basically turns on all the drought resistant properties, so that plants can basically survive in drought areas. My idea is more about having a chip that senses that hormone, since it's only secreted when plants are basically crying for help, right? Ben says interesting. Since this hormone is only secreted when plants are basically crying for help, if we can detect it, and because it's a hormone, it's a small molecule, which means therefore it will have an interplay in the electrical signaling, right? Like it will have a sodium versus potassium sort of like ionic interplay in the xylem vessel, right, which is where mostly the water is, right? And so if you were to insert a chip, and I did some customer research, it wouldn't be all plants. It likely would be like big, like deciduous trees, like almond trees, which is a lot of money because that's, or vines, that kind of stuff. More Life said, this one is a big idea, yeah? I know. This is why they gave me the big monies. But yeah.
You nailed it, Doc.
No.
Yeah, this one. Since we were working with him sensors to collect data from agriculture, from greenhouses, we never ever thought of getting into plants themselves.
Exactly. And why would you, right? But here on the call, you have a protein designer who actually can design something that can fit on your chips. And while it's on your chip, on your electrical chip, it will be detecting that specific signal, that signal of that hormone that is released when it's stressed, right? So now Lawrence and McGregor can focus on making a de novo protein that binds to this hormone. I'll tell you guys the name later, but it's this hormone binds to it while it is coated, while the de novo protein is coated on the chip, right? The chip that More Life would design, right? And so now you insert this chip in the into like almond trees. You can insert it. We can play around first with like maize trees, of course, because that's just a good model system. Maize crops anyway, like just a corn crop or whatever. We can play around with that first and see how it translates. But insert it in there. Now you're monitoring that electrical signal all throughout the plant's life cycle, and it can be translated via IoT, like Internet of Things, and this is more Life's area, but it can be translated as a signal to your phone. So now the farmer can get basically a heat map of his crops. Here are the ones on the edge that need watering. Here in the middle, they don't need water. So it's a way to save on water, right? Climate change. It's a way to distribute resources economically and effectively to the right place. So you're also now avoiding overwatering. One of the problems with climate change is that weather patterns have now shifted. So people cannot predict when it's going to rain and when it's not because things have shifted. So now you might water plants today because they haven't had water for so long, and tomorrow it starts raining. so now you have overwatered your plants, and that's an issue, right? But now because you can detect whether the plant itself is thirsty, if the plant itself needs water, that means you only give water to the plants that are showing the red areas that need water. So it's a really specific way to do this. And then the third thing that I love, and that is actually relevant now more than ever, is while we are collecting all of this information per plant, now we're talking about big data, because you're collecting information per plant, but it's per farm, per area, per region. And if we have a farm in Nigeria, a farm in Zimbabwe, a farm in France, a farm in Ohio, America, a farm in China, the weather patterns are going to be completely different across those globes, and we can aggregate data to train models that can better really, learn more about this plant signaling across, because the same type of plant, it's the same crop, right? All across, same chip, same hormone we're detecting, just different environments, different farms, different weather systems. And so we get to learn quite a lot in one go, especially with the cloud information and whatnot. And so this was the big idea that I had, and you can see why people threw money at me. And I had not a prototype, but I had a scaffold, the scaffold that we just talked about, and I showed the molecule that I made. Actually, I have that molecule here. But Lawrence, what do you think about the binding idea? Tell me do you think about the de novo protein idea?
Amazing. I love it so much.
Yeah,
So give us the protein. Give us the protein. All right. So we'll see if other proteins are bound to it. So we just want the protein. So if other proteins are bound to it, we'll truncate
it. It's not a protein. You have to make the protein, but the hormone is not a protein. The hormone is a small molecule. So you have to make a protein.
Okay.
Small molecule.
Okay, one protein that binds to a small molecule. Yeah, that's ligand MPNN, right? Is
Yeah,
you can use ligand MPNN.
you can use Ligat NPN, but yeah, you can use Rift Dock is another one that's out there. You can do docking systems. But yeah, this is the protein we were looking at in VR. I have a 3D printed model of it, and so the idea, and so this is the one that I was showing during that time and pitching, is that we basically had the scaffold, and what I'd been doing was carving out a hole. Remember, I showed you guys there's no hole here. It's all sort of hydrophobic interactions. I'd been carving out a hole here so I can then dock the small molecule there, and it would fit potentially there. And so I think when you start designing this, I think now with all these tools after fusion, you don't have to start with known backbones, right? But I think as you start pruning out different backbones, focus on ones that have beta sheet type topologies, because this hormone actually has its own native binding partners, and that natural binding partner actually has this similar shape. It's a really wide beta sheets type topology, and so if we want to learn from nature, we should definitely learn about that binding partner, right? I think as a prototype, we could even just take that actual natural binding partner while Lawrence and McGregor are going in parallel to to make a de novo version, right? And one also that is thermostable, that will be resistant in farms in all these different climates. So we need all of those features. We could just take the natural binding partner, the native protein binding partner, and coat it on a chip, because there are several things that MoLife also has to figure out about the chip, right? How does and this is the part that I never really got to. How do we translate a protein binding event to an electrical signal that could be then translated on a IFT? Do you have an idea of how to do that, MoLife? I think you're on mute.
So for my own part, Samuka, me and Mark will try using ligand MPNN
Yeah,
to
it's a good idea.
to,
Well,
to design
we need to pitch it though, so that we get the funds. Once we get the funds, then we can start doing all of this. Because if we get accepted and get the funds, what would be really great would be for Ben. I would love for you to reach out to farms in Zimbabwe right now and see who would be willing for us to use their farms. So we'd pay them, right, to basically, as part of the grant money. Can you hear me, Ben?
Yes,
Nobody
yes.
is. Okay. Yeah. We would pay them to plant a specific crop that we are doing, right? And then they get to keep the yield, they get to keep the growth, or all of whatever they get, the harvest. But we would pay them to do two plots, one with our chip and one without the chip. And what we are looking for is the data. Like, we want to get the data from the chip, of course, but then the ultimate yields, right? And we want them to weigh, okay, how much did they pay in terms of product from the no chip versus the chip, because the idea here is that our chip would actually result in higher yields, right? Because if you're watering things right on time when they should be watered, then likely they will grow faster, they will grow better. And so, the idea is that we have a higher yield. And so we need to be able to measure that. And so, Benny, you need to start, once we get the grant, if we get the grant, you need to start talking to different farms and plants. Lawrence and McGregor, you guys just have to start like making designs. You just have to take the hormone and start making designs. I think I would start by taking a look at the native protein that binds to the hormone, do some research about what that looks like, what is the binding mode, really understand what kind of protein would need to be needed to bind to that, because it's the ligand is also a special kind of ligand, like it's super hydrophobic as well. It's not just a regular ligand, and so you need to figure out what models would be useful. And then if you do make designs with ligand MPNN, how are you going to structurally validate them? How are you going to pick designs?
okay. Yeah. I don't know. We'll do our research. We'll make a lot of binders, because we can make binders that bind to the protein, that binds to the small molecule, but you want us to create new proteins that bind to the small molecule. So we'll look at our options, and we'll validate them based on their scores, purity, IPTM, if so. So I think so.
Well, well, the PLDT won't really give you much here because yes, you will find out your protein falls, which is fine. That's great, but we need to have a metric about ligand protein binding, right? Because what's important is that this protein binds to the ligand. And what metric will give us that? I mean, IPTM is good for protein-protein interactions. I don't know if it's good for ligand-protein interactions. And so you have to look into that a bit more, see what Bindcraft has to offer, look at Bolt, what do they have to offer for small molecule
Okay.
protein binding.
For small molecule, we before we started protein design, me and Mark we do computational chemistry. And all we do is molecular docking. So we use Pyrex. So you get a small molecule compound, let's say that exists in a plant, a phytochemical. Then
Mhm.
you find a protein. Let's say if you want to work on ulcer, you want to find a small molecule compound for ulcer. So you go to the PDB, look for a protein across ulcer. Then I can look for a native leaf, get the phytochemicals in that leaf, then do molecular docking. So the more negative the scores, the better the binding. That was literally what we'll do. Then we'll do admin properties. So we could also use that software, Parex, to see how well exactly they bind. But Mark, yeah, he's saying that you need a prototype, not just an idea. So you have to show something you actually built. That's
Right,
what they
that's where
say.
more life comes into place, right? Is because we would want him to start actually quoting, like so because he can work with the natural protein, the one that binds to the ligand natively to make a chip right now that binds to this specific hormone we're talking about. But more life, how do you translate from a biosensor to electrical signal to Wi-Fi? Do you have a good idea of how to do that?
Yes, what I can comment about that is usually the microchips that we work on IoT devices, they they extract electrical signals, and these electrical signals they interpret a certain pattern of a process or of a condition. So, for example, let me just give an example of a pH. Example of a pH. pH sensors, they detect a variability of pH. So they just extract the changes in electrical signals that are extracted from there, and then the microchip reads that. So I wanted to know whether whatever the molecule, whatever the protein that we may, I don't know the output, the end result of the binding that we are talking about, will it result into an electrical signal? But I'm
Yes.
sure somewhere,
Yeah.
somehow it might be. But now I have to then research further on the sizes of the electrical signals that can be generated there, and what best approach to extract them, because some of the voltages are very, very small, that you have to dictate that this signal translates to this. You get the sense?
Right, right. No. So there's something called SPR, and it's a technique for detecting binding events, whether it's protein-protein, ligand-protein events, and it's basically something called resonance, which is basically measuring weight distribution across an electrical signal sensor. If you look up SPR, it is the basis of where this idea would come from, because it's basically
Okay.
translating weight into a heuristic for binding, because it's a change in mass event that happens
Oh,
that's tied to like an electrical signal. I have no idea how that's tied to it, but it is
okay. Change of mass.
exactly.
Okay, yeah, I get it. Yeah, I am sure it's possible, because from there, once we get the signal, The rest will be very, very easy. Nowadays we can easily compute and design artificial intelligence models. That will be very easy with the what we call Raspberry Pi. If you heard about it.
Raspberry Pi. Yeah. So then you can use that to definitely that would essentially be like your little proof of concept model, right? That captures all of this data, train the model, and then you can use that to basically predict new things that are related to farming and agriculture. And actually, you guys, we have an expert on the call, expert entrepreneur, expert in multiple different areas who would be very, very awesome to have in this project idea. Hey, Takura, how's it going?
It's good. It's good, Dr. Moose. How is it going?
Drumo good you, man. This is
Yeah, this is great. But I'm happy to be here, though.
okay. Good to have you here. Thank you for joining the call. And actually, Takura participated in Stimulator Games season
Yeah,
2. Was it or season
yeah.
3?
It just season 3, I think. Yeah,
Oh, you signed up for both. Okay.
yeah,
You signed up for season 2 and season 3, and I think you also got to top 10 in season 2. I think.
yes.
Yeah. No, shout out to you. So we're actually talking about presenting all of this stuff that we've done over the past 6 seasons, as well as some of the side quests, experiments that we've been doing with Protein Design for Africa. We have Protein Design for Africa on the call, represented by Lawrence Jaboro, as well as McGregory, who are both students at the University of Benin in Nigeria. They're currently in Nigeria there. We also have on the call More Life, who actually participated in season, I don't remember, season 2, maybe season 3. I don't even know. I don't remember. Oh, maybe season 4. But More Life, you might have met him actually during Task, I think, which is where we met, Takura, where you presented your topic together with Ben. I don't know if it's the same year because all the years are. I'm getting old now. All the years are in my head jumbling up. But where you guys presented your entrepreneurial ideas for a competition, it was like a pitch competition type thing. And Ben also is our business person, finance person. And actually, Ben, this thing that you found, this is exactly it. This is it. I'm seeing the folks in Israel are the ones who posted this, but I think they're citing the paper from the folks in Duke University because that figure is definitely from the paper that I was talking about from Duke University. And so that's it. That's actually it. What we're talking about. And then Takura actually, and feel free to introduce yourself, Takura, but I will say a little bit something. Takura actually is a serial entrepreneur at this point. He has built several businesses over and over again. He's currently building a money remittance type business right now. Things are like he's gained so much experience in terms of building companies on the African continent, social media strategy campaigns associated with marketing, lessons learned with recruiting investors across the global, diaspora, as well as tying things to the urgent need of the customer and being able to deliver on executables and stuff. So honestly, Takura, you would also be a valuable voice in this project and endeavor. We are planning to apply for a grant to be able to launch essentially this idea of solving climate change through biochemistry and electrical engineering, and using this basically building a company around it essentially. So we're pitching this to this innovation fund. If you look in the private chat, you'll see the link to it. I think it's the second link from McGregory. If you look in the private chat, you can click to that link to catch up a little bit on what we're talking about. But I think you would be very much interested. You are a serial entrepreneur. As much as I know you jump on a lot of these good ideas, and you'll be happy to know this idea has already been vetted a little bit by myself, yours truly. I won accumulation of, it was 10,000 was the highest number that I won, but it was accumulation of multiple awards, and the largest one was 10,000. So I think in total it was probably like 20,000 for pitching this idea back in 2018 or something, when I just thought it was just an idea. And years later, several labs have now published things that prove that this is entirely possible. But I don't believe there's an actual chip that's on the market. This paper that or this article that Ben then posted. I think it's the closest thing. I was trying to figure out when it was posted. Can you tell, Ben, when it was posted? I think I'm the only one who's not on mute.
Let me check. Let me check.
Okay.
I was actually looking at something else, but this I'm not sure. Let me get more information. I'll tell you. I'll tell you if I get something.
Okay, and then the references that are in there, that's the first reference. That's the Duke article actually that I was talking about. Yeah, so they're all
Okay.
connected. They're all tied together.
Mhm.
And More Life says LiDAR, light detection and ranging and imaging techniques may also be explored. Yep, that's what they used in that link that Ben shared. That's exactly what they used. So Takura, why don't you introduce yourself to the class and tell us so far your thoughts so far? And I know we're also discussing about how Stimulator can help currently your businesses and investor ventures, and what we will be doing together. But yeah, maybe just do a quick introduction just so that folks know a little bit about you.
Thank you, Dr. Mook. I don't think anyone could have done a better introduction than what you did. But hi, guys. Nice to meet you. My name is Takura. I'm currently building a payments platform. It's called NadoPay. So it allows people across Africa to receive payments from any other country in Africa and abroad as well, from any currency, any payment method, and any wallet into your own native and local currency. So if you're in Zimbabwe, you can send a payment link to someone in Kenya. They pay you with M-Pesa, receive the money via EcoCash. You can send the link to someone in the States. They pay you via PayPal. You can send the link to someone in Ghana. They send you CDs. You receive USD in Zim. Or you can do it even outside of Zim. If you're in Ghana, you can send to someone in Kenya, and there'll be the Kenyan shillings to CDs conversion. So that's what we're doing so far. We're in 13 countries now. Very significant partnerships throughout the continent. I was doing a pitch competition yesterday. Eventually won first place. So
Did you really? Oh
yeah.
my God! Congratulations! What competition is this?
My school was doing Mastercard Foundation. They sponsored ventures in Southern Africa, and that's what it is.
Mastercard. Oh, so how much did you win if it's Mastercard? Takura, how much did you win if it's first place for a Mastercard competition? How much did you win?
It was 10,000.
Jesus! Wow! Wow! Congratulations! You deserve. You really deserve. That's
Yeah,
amazing.
thank you so much.
First place. I wish I had the drum roll to to do a congratulations, a proper congratulations. Well done. We're so happy for that. And then, like, Chakura, now you just focused on not to pay because that is your current baby. It's what you are you are moving forward. But please give us a brief history of the previous entrepreneurship opportunities and journeys that you have gone through. Because I describe you as a serial entrepreneur because you really are somebody who identifies the opportunity where it meets with your skills and talents, and you're able to maximize, and galvanize opportunity for that. So please tell us a little bit about the different companies that you have already sort
So
of played around with past. Yeah.
I think I'll just go backwards. So recently, before I started doing NadoPay, I was doing a startup in agri-tech with my friends. It was called Smartel. We're doing hydroponics. So we're in Nigeria and Rwanda, just doing vertical farming systems for climate vulnerable communities, making sure that they can absorb climate shocks and they'll be able to grow food sustainably without facing any of these climate effects. That startup was going well. We got selected for Google for startups. That was my main driver. That's what I was feeding from. I learned multiple lessons from there. Learned how to be a leader. I wasn't exactly CEO at the time. I was chief operations officer, but that was like proper startup. Before that, there's a time when my sister and I were doing a challenge. We're trying to get $1 million by the end of the year, but mainly the whole point was to show people that there are business opportunities just lying around and they're easily accessible, and you don't need like excessive capital and things like that. So we're starting multiple businesses, retail mainly. So we're selling socks, we sold Crocs, we did a social media management agency, we did a printing business, and we're just doing businesses all over so that we would hit our goal. Unfortunately, we didn't get $1 million, but the journey was worthwhile, and that was good. Then prior to that,
And it
I
taught
knew.
you how to talk about, failure and ups and downs or whatever. It taught me how to
Yeah,
talk to different
because I was
investors.
documenting that journey every single day on this is what's happening, these are the good things, these are the bad things. Yeah, and I also started a blog after that because now I was just writing about my life. It was just good, just talking about your life and getting the support. It's also easier to get support from people if people know what you're doing because they know where to invest in you and things like that. When we met with Dr. Mook, it was Task. I applied with a job creation platform. Um, we're connecting people who are looking for jobs and people who were
Yes,
getting jobs.
the
Yeah.
internship idea. Yes. I remember now. It was a lot. It was a lot, but yes. Did that take off? What did you end up doing with that? Yeah.
uh, that didn't take off. I was still very young, but it was also like my very, very first idea at the time.
But you were top
And
5, right? You won at least some money.
yeah, I was top five.
You
Yeah.
won like how much? Like $100 or something?
Yes, it was $100 at the time.
And so, what did you do with my money if you didn't pursue your your idea? If you're saying you didn't do it, what did you
No,
do?
it didn't take off at the time, but to we tried to do an MVP. Then we went for a couple of pitch competitions. Then we recruited people to make it, but it was now the onboarding of companies and finding students that was now a bit taxing. And I
Yeah,
was also starting uni at the time, so
yeah.
everything was too much. Then we just left it.
It's so funny. People don't know this. You guys don't even know this. We were talking about me pitching this idea, the one that we're talking about now, Chibage Chip, to to do this, and I won 10K. At this final ultimate competition, and the competition was just for the idea. I didn't do the idea at all. I didn't even pursue it
Yeah.
whatsoever. It was just for the idea, and that's where the idea for task came from.
Oh,
Like
that's
people
crazy.
don't realize, people don't even know that background is that I thought like task this pitch competition so that young Zimbabweans can pitch their ideas and even the COVID solutions, the task 2020. Because wait, were you on task 2020 or you were before task 2020,
I
Takura?
was after 2021, I think.
2021. Okay. Because task
Yeah.
2020 was really this idea of okay, let's try to find solutions towards COVID and business solutions, and that was a whole endeavor. But it was inspired by Chibage Chip and my experience with that. Yeah. And so, okay, so now Nadope, this is where we're at, and things are looking good. In fact, you've just won a competition, pitch competition for $10,000. What? And so that is awesome. And you participated in Stimulator Games, which it means you are eligible for not only, of course, more investment, but also to participate in these downstream activities that are happening. One, we're doing the conference with Abercamps where we're going to present all this stuff. It's an opportunity to win as well, but also a good opportunity to present this work because you will be talking to judges and recruiters from all over America, from Yale, from Harvard, from Novartis, where I used to work. I actually recruited students from this same conference. And no better person can tell you about this conference more than she got her real name on here now. I was gonna say Kamara Ice, but Damari Morgan, I guess that even feels weird saying.
Let me go change
Hello.
it. Let me go change it.
No, but I say this to say Takura and Kamara, you guys have actually met, as well as Ben. I think More Life, you might have met with them as well during Stimulator Games. McGregory and Lawrence, I think maybe you know them as casual viewers, but I don't think you've actually interacted in the Stimulator Games. But Kamara Eyes, aka Damari Morgan, is is our two-time winning champ for Stimulator Games season 1 and season 2. She was also a teaching assistant for season 3, and she has actually presented this work at Abercamps in person. So More Life was able to present his work that we talked about earlier on virtually. So did Linda in Ghana, as well as Kudzai. I think she presented while she was in Zimbabwe. I forget one other person. Oh, Ben is in the chat being spicy. Put these chat comments in the comments so that I can put them on the screen because all I see on the comments right now is Tia. And then Ben said, "Anybody home?" Put these in the comments so I put them on the screen. But no, Kamara actually presented in person. Her and Ama Nicole made posters. We flew out to Arizona. Yes, they got flued out by Stimulator. The chat is a lot right now, but yeah, and so she can tell you a lot about Abercamps and the potential opportunities that is there to meet people, to interact with folks, and not only I'm thinking Takura also to get investors, okay? Because these are a lot of the professors and biotech folks and scientists who are there are wealthy individuals looking to invest in startups across the globe. And they are students. Majority are students. 5,000 are students. It's the largest biomedical conference for minoritized students in the world, and so majority are students, but students who knows, maybe are could be your future employees over there at Nadope. And then because it is, of course, uh, uh, specifically underrepresented minority students, there's a huge contingency of Black students. Obviously majority are Black, but there's also a huge contingency of African students who might be your customers for Nadope. And so I think it's a good opportunity regardless for you to present there and represent also Stimulator from Rwanda. Because are you currently in Rwanda? Where are you at, Takwara, before Kamara takes the microphone and talks a little bit more about Abercamps?
So right now I'm in Zimbabwe. I just arrived for the pitch competition, but I'm going back to Rwanda in a few weeks.
When do you graduate?
Oh, I just did 10 days
Ah,
ago.
congratulations! We have graduates all over the board. Okay, congratulations. You graduated from the University of what again?
Africa Leadership University.
Uh-huh. And this is in Rwanda.
This is in Rwanda, yes.
Wow, wow. So how long will you be a student, considered a student there? Because this is important.
The student offer letter expires in November because our program is 4 years. I just did the accelerated path to finish in 3 years, but I'm
Uh-huh.
still a student up until November.
November, how much?
It doesn't say the specific date, but November this year.
Okay, great. Because the conference is in
Yeah.
November. The conference is in
Okay.
November. So the conference is November 18 to the 21st. And I think you have to be a student at the time of application. I don't think you have to be a student at the time of presentation. I'm not sure. But I will double check that. But
No,
for
I'm,
sure,
I'm
when
pretty sure. I'm pretty sure I have confirmation that I'll be a student. I'm going for a debate competition in Canada in December to represent my university. So, they would have that sorted out
where in
already.
Canada?
Ottawa.
Ottawa. Okay. Because the Abercamps is in Seattle, which is right by the border of Canada and America,
Okay.
actually close to Vancouver, actually. But okay, all right. So you will still be a student. Okay, great. So
Yeah.
I think you can submit your abstract as a student of this Leadership Institute, and on behalf also of Stimulator for the work that you did. So I don't know. Yeah, I'm leading. I'm bearing the lead, but I'll tell you guys about the lab results very soon. Particularly Takura and More Life and Ben, you're going to be very interested about these lab results. McGregory and Lawrence already have their own lab results that that is separate from these lab results, but they are ones that you guys have worked on in simulator games, and so I'll tell you about that very soon. But let's let Damari Morgan come to the stage and introduce yourself first of all, and then tell us a little bit about your experience at Abercamps and what people can have expect to have in store for them. Yeah.
Okay, so hi y'all. Um, my name is Kamara. Don't look at the first two names there. That's for government purposes. I forgot all about that with Google. So, but yeah, so y'all know me, Kamara. Hey Takura. Hey Ben. um, I first of all, y'all were great competitors. I mean, y'all would have won, but the favors were upon me at the time. But you know how y'all hung in the game, so I'm gonna just keep wearing that little crown. Anyway.
Jesus Christ.
Okay, so Abercamps is super fun. I was super I was nervous as heck. But it's very fun, and it is a lot of students and professors there. I met a lot of people. I couldn't do nothing necessarily because but I met a lot of people, and a lot of opportunities was on the table, but you do need certain um backgrounds, I would say. Like, you guys all graduated with some nice little degrees and stuff, so you guys will all qualify for all of the opportunities that they have there for furthering education, it's a lot of job opportunities actually, in pharmaceuticals in that area. It's like a lot going on. I just took people goodie bags off they off they table. But it's very fun, and when presenting the abstract, it's like, okay, I was nervous at first because I only know so much from stimulated games, from Steam Olympics at the time. But the more you talk about it, and you have other students that come across and ask about the abstracts and stuff too, what you're working on, and it's like, okay, everyone weighs in and gives their opinion on what they think you discovered, or what they think your avenue or pathway is, or your idea. And then that, I don't know, that provides a lot of comfort in it, because it's like, okay, I ain't the only one who has belief in this idea. And then when the professionals or the professors come in and be like, oh, well, tell me about it. It's like, ooh. And then when they give you like a little thumbs up, it's like, okay, you're going down the right path. This is good. This is good. So it's a very encouraging environment overall. And yeah, y'all should come.
Yeah, and you have the opportunity to not only present your work, but you can also win. It's a competition, So they give prizes across different disciplines. So you have multiple opportunities to win, virtual and in person. They give separate prizes. So it's definitely an opportunity to win money. And then, yes, it goes on the resume because you're presenting at an international conference. That definitely is a resume builder. And everybody who's presenting at AbriCamps is definitely, I mean, you're definitely part of the paper for sure that we're writing up about these molecules in the first paper. But if you're presenting at AbriCamps, you'll be part of a separate paper that is about essentially learning and this educational platform that we're doing. So you get 2 for the price of 1 for just presenting this stuff at Stimulator. So I'm pretty excited about that. Who did we lose? Did we lose Ben? Who did we lose?
More Life.
More Life. Oh, damn. Because More Life presented virtually. And so, yeah. So, Kamara, I don't know how much you caught when you were watching from the audience and not joining us on here, but we are preparing for AbriCamps, but we're also preparing for this other innovation grant that we're about to apply to. It's really this, I think the idea is now coalescing on this idea that I pitched during my grad school times. Actually, I can see it right here. Let me share this.
Back in 2018. I was there. I was listening.
You were listening? Okay, so I was able to scroll back, you guys. Okay, so now you don't have to see all my other stuff, but I scrolled back to because I was trying to look for the very first thing. It was $100. I remember that. It was $100 that I pitched, and I got. It was a 5-minute pitch, 1-minute pitch competition. Yes, here we go. 1-minute pitch competition on Venmo. They gave me $100, and I remember telling my sister. My sister. This was at the Entrepreneurship Venture Capital Club. This was the very first time I pitched this idea of Chibage chip, this idea of a physical chip, prototype chip, that you inject into plants, whether it's almond trees or maize, because Chibage is maize, and it detects this hormone that is a signal for drought and thirst, essentially. And so that signal will then be transmitted through IoT device to your phone, and you can make a heat map of your whole farm of which plants need to be watered and which don't need to be watered, allowing you to allocate resources to where exactly they need efficiently, as well as with minimizing waste, overwatering, all while capturing data in this much larger system that could be used to train a model to better predict plant behavior. We can't predict weather patterns anymore because of global warming, so this would be a great tool in the toolbox of farmers, particularly in third world countries, to really navigate this climate change system. So that was the idea, and it hinges between protein design, electrical engineering, as well as agriculture and farming, of course, wrapped up in climate change. And of course, I think it would make for a good business. And it's only matured over the years since I pitched the idea. This was the very first time I did it. You had to have, it was 7 judges. You had to have you had to have 4 or more green cups, because they raised green cups or red cups. I had 7 green cups. Okay, of all 7. So I had $100. I remember telling my sister, she's like, "Does that mean you're going to the next round?" And for sure I did. I went to the next round. So that $100, and then the next thing I pitched, I won second place at this thing. I won $500. This was University of Washington Science and Technology Showcase, and I actually had a poster that I presented. And so this is Carla. Actually, Carla was another, I think at the time she was a postdoc in the neighboring lab under the same umbrella, Institute for Protein Design. She was in the King lab while I was in the Baker lab, and she was a postdoc, I believe. A postdoc, or because she wasn't a graduate, because she got actually her PhD in physics. And so, which was very valuable for our conversation of figuring out, okay, would this thing even work or whatnot? At the time, I already had the scaffolds for ligand binding, and Ian Haydon actually made these figures, which was really great for the science communication component of this, to really communicate what we were trying to do to investors and to a larger set. But yeah, this was the second thing that we did, and we won $500, and it was only up from there, because after the $500, then so this is what is this? So then we won $2,200 from, this was Alaska Airlines Environmental Innovation Challenge. Congratulations, your team has been allocated funds to help move your prototype proposal forward. And so yeah, we got $2,200. This was a crazy time, you guys, because you can imagine every competition I was going into, where people were pitching things like, we are the Uber for stickers, that kind of stuff. And then I would walk in and be like, so I make molecules from scratch, and I would like to solve climate change. And so it was one after the other. So that 2,200, that's what we used to start doing customer research. Which meant basically I flew around the country. I went back to Cleveland. I went to Clemson University, speaking to farmers, trying to figure out, what is the right mode of this. At the same time, I was developing my hip hop biochemistry stuff that now you guys know is Stimulator Games. And so this was actually me presenting. So I was still a grad student, by the way. So I had my research proposal that I was presenting at this conference. But because I also had the poster from my business company, I basically presented 2 posters at the same time, because greedy, and also because why not? I could go ahead and be an overachiever. But it was also good to get feedback from professors, particularly plant biology professors, because at the time I was just like, is this even a thing? Like, is this real or what? What's going on? And I was getting mixed signals at the time, but ended up being, a pretty real thing. And then this is the one thing I did not get, because I did apply to AT&T's scholarship thing. I think it was a lot of money. It was like 70 grand or something like that. And so I tried to tie the competition stuff with the hip hop biochemistry stuff, and it wasn't great. So that didn't fly. But the wins didn't stop there, or kept on going. What is this? Shout out to Claflin University for the. Oh, because so I went to Claflin. Yep. So this was also part of all of this. No, so let me show you the money, because that's why people want to know about the money, the final tally. Oh yeah, because we won this one as well. 15 grand. Yep, this was 15 grand for the Burke Sieber, and then I got lawyers for free pro bono, which was basically I think it was $6,000 worth of lawyer fees that they started helping us with IP and talking about next stages. It was all free by winning that whatever competition it was called the Law Clinic or something like that. And then I don't remember what this is, but yeah, Ian Hayden actually made this logo for us, the Chibage Chip, the maze, with somebody, I think supposed to be electricity or something. And then I pitched this idea at a bar, and then I graduated in the middle of all of this. I graduated with my master's, my master's, and I continued on with my PhD. So Thelma actually is a Zimbabwean. scientist at the University of Zimbabwe. You guys should contact her, Thelma Madzima, a very nice lady, very nice scientist. And she was a plant biologist who was a Zimbabwean. I was like, oh my God, this is perfect. So not only was she my advisor, faculty advisor for a lot of the stuff that we were doing for Chibaki Chip, but also she ended up being on my committee, my dissertation committee, as my PhD committee, as one of my my committee members and advisors. So it was really awesome. I got to meet these African students, Africa Now. I ended up donating, I think it was like $500 for their cause because they were doing something for Pan-African youth across the diaspora. And so you can see these are all different countries, all aggregated in the lab. It was pretty cool. It was pretty awesome. I think now where's the final check? The final check is like, then we won this thing. How much was this? It was the NSF ICORP grant. Yeah, we won NSF ICORP grant. I think this was $7K or something like that. I forget how much this was. But we won this, and this was basically to do more customer evaluation. This is when I went to Clemson University, CoMotion, and then a bunch of different places to talk to actual farmers in America. And that's what I discovered. Farmers in America, completely different from farmers in Zimbabwe or across the globe. Oh yeah, this is it. So when I donated the 500 that I won in that second competition I told you guys, I donated that same 500 essentially to Africa for Now, this group. And this is us presenting the check with my belly out like that. This is before I was doing exercises. Oh, this is also when the shirt was so famous. So I designed this shirt with, this is my fraternity brother, Baba Freak, who owns a fashion company. What is it called? Baba Freak. Yeah, I think that's the name of his fashion company. And we designed this shirt, which is the geographic map of Zimbabwe. You can actually see it's a little teapot. And it's made of the Kente print, which is the Ghanaian print, traditional print. Sewn in Nigeria by his company. He's from Nigeria. Baba Tunde is from Nigeria. And so he sewed this in Nigeria. These shirts were shipped from Nigeria. He was working for Delta Airlines, so he got some cheap mileage, okay, to America. And then it was also a collaboration between two brothers because we're both members of Alpha Phi Alpha. And so these are also my other brothers in Alpha Phi Alpha. Alex wearing the shirt in blue, and then these are two of my neos that I met while I was there. This was a whole whirlwind of a time as well. And we need to bring that design back because that was something. All right, the last thing is there we go. So the last thing was the actual pitch day. This was high intense because everybody came around. It was very much like Abacamps, actually. Everybody came around, investors coming around, wanting to know more about the idea. And I had it set up. It was not just the poster, but it was also my lab actually bought me like this hydroponics thing to show basically futuristic plant what the potential of this chip could do, right? Because we could train a model that you could just plug into these sort of like aquaponics things like Takura was talking about. But this thing would be almost like a self-watering system that has been trained on the knowledge of different crops from different areas and different climates and this kind of stuff. Yeah, so that was the like my little setup and desk, and you can see Chibage Chip on the desk. And I ended up just being me presenting because I think Carla actually at the time was traveling to Europe. I think at the time, yeah. And I'm giving, even at this time, I'm giving shout outs to Nikki. What is that about? What does Nikki have to do with this? What did I say? I said, I'm still gonna do what my parents said me to do. Just kill. Oh, okay. The win again. Yeah. See, I'm crazy, y'all. I'm crazy. But anyway, I won 5,000 for the environmental. It was like a special award. It was like community impact prize. There we go. It says so at the bottom right here. 5,000 community impact award, and then I also won 5,000 for coming on third overall. It was something, I'm telling you. I set up this table myself. I was dirty by the end of it because I had dirt from so I was showing situations in Africa, and then middle type situations, and then the hydroponics was like first world, and so I was showing sort of like the inequality of farming across the different landscape. And so I had to bring dirt in a tray, and so I came in looking all kinds of shabby, and then I went to the bathroom, changed into my suit and my little Zimbabwe shirt. People could not recognize me, child, and then I was full on talking about science and ended up winning 2 chicks. It was crazy. People were upset with me, particularly the people who were next to us. They were. I think that was the Uber for stickers. I think so. I remember their pitch, which I was just like, Interesting. But I remember them looking at me because I was like, oh, it's so many checks. I was like, it's so many checks, so heavy. Can somebody help me? Which I was being petty, but it was fun. It was fun. I don't care. Yeah, and they did this write up, which was so nice. Earth Lab, UW Earth Lab, and the wonderful thing was this was a prize for the idea. Like you didn't actually have to action on it, and I had honestly I had no plans on actioning on it. The great thing is I ended up being able to use all of those funds for my parents to come for graduation, which ended up being just amazing. This is I think the day that I presented. I did my dissertation the day I defended, and my dissertation is somewhere here. The actual flyer. Oh, where is it? Because this, yeah, here we go. This is my dissertation defense. This is my actual topic. Shout out to the folks who came to this. Very excited about that. And then yeah, I'm just gonna show this video one more time because I love it. Yeah, but yeah, my parents came and we went to every graduation. This is where the 10,000 is all over here. This is what we did with the money. We went to every single graduation. We went to 6 graduations in total. These are all folks who were able to show up, which was really awesome. My best friend, my sister, my mom, my 2 best friends actually, and then with my sister who's also been here the whole time. So yeah, my cousin sister from my mom's side, Shinky. My dad as well in Seattle. That was awesome. That was super awesome. And so I'll show this last video one more time because I love it.
Team Siku, a member of the David Baker Lab, who's graduating with a PhD in biochemistry and biological physics, structure, and design. Again, he will be put by Dr. Jorge Flores, his doubleheader today as well. The thesis title is Structural Insights from Beta Sandwich Proteins Inform the Design of De Novo Immunoglobulin Domains Towards New Age Antibodies.
Look at his face. And that's my mom doing the ululation. The Zimbabwe is so Zimbabwean. Oh my gosh. But yeah, you guys, that's the whole deal. That's the whole deal. So I think Chibagi Chip makes sense for us to do. So we will do that. We will move forward with that. I think there's a different combinations of things that we will do. Protein Design for Africa will handle the protein design element of it. More Life will handle the engineering element of it, the physics-based portion. I think Ben can definitely source the farmers on the ground who will potentially be our guinea pigs, because we can basically just be like, hey, here's the money to purchase seed. Do A with our chip, B without the chip, give us the data, keep the crops, but give us the data of what, basically was successful or not, because we also want to evaluate, is this actually productive? And then Takura, hey, we need a CEO. We need a CEO. You a CEO.
Oh my God.
And also like somebody who would reach out to farms across the continent, because we also want to show that this is replicable, not just in Zimbabwe, but across the continent, which would be very interesting to do. Would you be interested, Takura? You haven't really said.
Of course, I'd be interested, and I think I can help. I think we have a list of farmers, especially across Nigeria and Rwanda. So yeah.
Okay. All right, you're interested. I don't know if you have the time, okay? Because sir, you're so busy. You're so busy to even collect money. You're so busy. You are winning money every day. So no. Okay, all right. So what we'll do next is definitely Abercamps on this, and Camara is going to be our face for all of this. Camara is definitely going to. We're putting you through it. Okay, come on, showing the face. Okay, all right. I was gonna ask everybody to show their face before they all logged off. I guess the internet packages definitely were not going to survive this long stream, but Takura, yeah, you can put on your camera just real quick, just so we see you and Camara real quick with the camera on, just a little bit. Where you at, Takura? There we go. Okay. This is going to be a great screenshot. This is the thumbnail you got. I should have done this with the thumbnail. Yes, there we go. Yeah. All right. Well, thank you so much. I'm not going to take too much more of your time, Takura. I know you are very much of a busy man. Feel free to stick around if you want to, but we won't take too much of your time. What you should do is definitely create your account for Abercamps and then send me your login stuff. I will pay for your registration, and then we'll submit your abstract at a later date. We definitely want you representing Stimulator, so you definitely should have the poster there. It would be great if you actually present the poster. I don't know if you will have the time to do it, but it would be great to just present the poster in that little 1 hour slot and whatnot. And the deliverables that we'll talk about later. But yeah, just submitting the abstract basically covers what you and I agreed on, and hopefully you get accepted, which would be great. But that's not part of the contingency, and so and I want to know more about NatoPay moving forward, and so for sure we'll chat some more. Okay.
Of course, I would make time to present, and I would love to be a part of this completely. If you could also send me more about the Chibage chip so that we see how we can start getting things rolling this side as well.
Yeah. And then there's in the private chat, you should see there's a few links about it actually. It's not going to be called Chibage chip because I think I need to retire that name. It's tied to a whole different period in my life and whatnot. And then so much research has happened since then to really validate that the idea actually was great, and not research on my end. I didn't even do it. And so if you look at this article that Ben posted that shows a really great review of what is out there, what is possible. And then that has references to some scientific papers. I will send you more about what I pitched in the past. And then we'll use those two things. The only thing we want to do right now is just prepare for this grant submission at the end of August. Once we submit that, we'll wait and see what that does. If we get the grant money, then that's great. If not, also, I think we're still moving forward. So either way, we'll see what happens, okay? But all right, talk soon. And congrats again, 10K.
Thank you so much.
It's a bank. All right, take care. Right.
Thanks.
Where's Kamara? Put your camera on. Kamara, what's going on? Oh, she's in the backstage. Okay.
What happened was I couldn't hear Takura, and so I went on YouTube to stream right through YouTube so I could hear. I couldn't hear him, and so that's what happened.
I see. I saw Anisu came on.
Oh my gosh, and now I can't hear you. This sucks. But
what?
I was able to hear Takura. I gotta go back on the other side, I think. I don't know.
You can't hear me?
No.
Oh, well, go and come back.
Okay, I'm gonna go back on the other side.
Okay. All right. And then Anisu, I just saw you come back.
Okay.
Can you hear me now?
Yes, I can.
I guess you have to have both on.
Can
you hear me still? Can you hear me still?
I can hear you now.
Okay, so you have to have both on, it seems like. Can you hear me now?
Yes.
Yeah, so you have to have both on. So what is for audio? What is for you? I don't know.
I don't know.
Okay. All right. It's fine. We're here with it. Okay. Come on. We finally made it. Okay.
We did. Hi.
And it's been a great day. Can you hear me still?
Yes.
Okay. It's been a great day. We were able to cover quite a bit. I've been live since what? 9? Since 9. But yeah. We are doing it. We are doing our big one, and we are submitting. So you want a crash course, and so it's going to start eventually. But let's just do a quick review
right now.
Let's start right now. Let's see, so I can figure out where we're going to start. Okay. So we're going to 2 conferences, right? We're going to the hip hop conference, and then we're going to go to Abercamps.
Yes.
Yeah, and the hip hop conference is in DC. Hopefully, we get accepted because that's the first time our paper will actually go out. Which, oh my God, that would be amazing. And that's a completely different audience than the Abercamps audience. Like it's completely different, but it's part of why this is great, right? We hip hop biochemistry. You know what I mean? Like we do half and half, and not even half and half. We do both. We do double. And so at the hip hop conference, what you need to know about is basically the history of hip hop biochemistry, right? Why was it started, right? So, do you remember where hip hop biochemistry came from?
What I remember is that you used to make clip. I see, Auntie. You used to make clips of your research on YouTube and try to teach the similarities or the connection between protein design and music, and then from that, because it's kind of foggy. From that, I remember learning about it on AMP, and you would have to teach us the protein language so that we could understand how to put a sequence together.
Yep.
And then I think that's pretty much what that is, right?
No, that's true. That is completely true. I'm actually pulling up the video right now. This is the video, the first video where I showed. Share this tab instead. You can watch this later, but this would be a good sort of like.
Yes.
So watch it a little bit later. Did I graduate?
I showed it.
But I won't get into all of that right here. At least not just quite yet. I mean, if you want to watch my full commencement speech that I gave when I received my PhD in biochemistry at the University of Washington during the lavender graduation, then simply click here. I will put the whole video up here for you to watch. But you didn't click this video for that. No, you came here to join me on this journey as we find out the rhyme and reason behind biochemistry. If hip hop speaks truth to power, and education is power, then what can we learn from our favorite hip hop artists? For specific protein in HIV, which for me and Nicki Minaj's dad is actually a very intriguing concept for me. And it also helps that I am a full-fledged Barb, which is a Nicki Minaj stan. By one of my favorite talk show hosts. What's her name? I might have lost you with that one, but that's okay. Don't worry. Let me back up and properly reintroduce myself. Okay, I did. Okay, so you stop this because Nikki don't play when it comes to licensing. Ooh, they don't play over there at Heavy On It. They don't play. I tell you, at Universal, they do not play. I'm telling you. Strikes all across the board. And actually, it's fine because I want to redo this walk, this exact walk. Okay, I want to redo this. If I could do it in the lab, that would be great. But the lab in Seattle, I don't know if I could do it. I don't think so. I don't know. It would be great. But I want to redo it now with the song. Because actually, come here. I made a new song today in the morning on TikTok.
Ooh, Moana's theme came out.
Moana's theme, no, wow. So Moana's theme, yeah, I mean, it was Moana's theme actually, because he's been growing, you know. He went from childhood age to teenage years, and his adult phase there's a whole song where he does a back and forth with the girl, you know, back and forth. He's learning life, you know. And then there's a whole love song where he kind of figures himself out, his journey. And then the very last song is basically a celebration to, you know, the company that he has now built and this platform that he's moving forward to. And that's this last song that I did today. And I'm going to just play I don't care. I'm gonna play the whole thing because the rise, just pyramids when knowledge never dies. Burn that boy's fire, tell me soulful beam. From Africa's art, we launch our steam. Liberia's promise, freedom's first light. Then we cross the Atlantic, America's in sight. From Hefe and Haiti to Nick and Cali M, we freeze up North Canada's them. Okay, I'm gonna stop there.
I like it. Not you got a bar.
Stop there, bars, exactly. No, I want to stop there, and then I'm gonna go to the very end because I want you to see how it ends. Steam rules the world, and I will not see you later. I will steam you later. Steam you later.
Not you gave a little shout out to the island crew with the beat.
I think I got a little hit on me. I don't know.
I like it. I like it. I need to hear the whole thing because you cut it short. No, the bar was bar.
I had there's some surprises there for a few people. Yeah, some surprises.
I heard the shout outs.
No, and it's not out at all. So we'll see what happens with that. And this is live. But I mean, I made it while I was on TikTok. So those who were on live, they were able to see it. But anyway, I don't know how this music business works. I have no idea. I'm just getting in there and doing all things. All right, so that's the background of hip hop icons. It started off as explaining biochemical molecules using hip hop analogies, right? So using Nicki Minaj's Billboard hits as a representation of the hits in biochemistry. So like her first Billboard entry, I used myoglobin, which is the first structure that we were able to get, right? Why are structures important in proteins molecules? Why is it important that we know the structure, of a protein molecule?
Do you mean like the chain, like how it binds together? Like, is that what you're talking about?
No, just like the shape. Like why is the shape important? The structure.
So you can know how it fits.
Yep. And so if you know how it fits, then you know how it functions. So structure and function are tied together. And that's the whole reason why this field works, why we're all in this field. And there's a whole subsection of biochemistry called structural biology. And this is true not only in the molecular level, but it's true in our world, right? Pots are shaped in a specific way to be able to hold the food that we're heating up and all this kind of stuff. Teapots are shaped in a specific way to accommodate as much water as possible and then have a spout for steam to come out so that you still boil your water. So there's a shape that fits the function. Same thing with proteins. Myoglobin is shaped in a specific way so it can bond to iron, and that's why it has that color red. That's why beef is red, right? Because iron, myoglobin is located in your muscle cells, right? And so it stores oxygen in your muscle cells in case you need to fight or flight, run. So you have that storage, the capacity of oxygen. And so that's so it's shaped in that specific way to bind to iron, but also to be able to hold and store oxygen. And then we know function is tied to structure. What defines the structure of a protein?
The amount of amino acids in the protein.
Yeah. The amount and what? In the what?
And the protein.
What were you going to say? Yes, the sequence, the amount, the sequence, and of course the identity, right, of the amino acids, the building blocks that form these proteins. So we know sequence informs structure, structure informs function. Therefore, so function is informed by what?
Say again, functions what?
So sequence informs structure, structure informs function. So therefore, function is informed by what?
Function is informed by the structure and the... You confuse me.
And sequence, right? Because if sequence informs the structure.
And the structure makes the protein then be to fit where it needs to fit.
So sequence basically informs function, right?
Yes.
So the way you have the order of sequence, as well as the amount of amino acids, as well as the composition of amino acid, informs what the protein is going to do, right? Yeah. And that's why the color theory we did, right, of being able to assign a color to every one of the amino acids. How many amino acids are there?
Well, if they're linked to every letter, it's about 26 now, right? But before there was like 20. So
yes, that's correct. Yes, that's correct. There are 20 naturally occurring amino acids that are classical amino acids. There are 2 extra ones that give us a 22 of, unusual amino acids. And then there are 4 letters that can be used to represent some of those other 20 amino acids. And that's why we're at 26 for the alphabet. I want to welcome onto the stage, actually, somebody real quick before we continue this conversation. I just want to welcome Anes, who's actually in Namibia, actually. And so she's trying to connect. She's been trying to connect for some time. She's at a university in Namibia. We're trying to get that connection piece there. We have Rwanda, we have Ghana, we have Nigeria, we have South Africa, Zimbabwe, America, of course. We need to get a few more countries. There are 54 in Africa, so we need to get a few more, but Namibia is one of them. So what I'm showing here in terms of the colors that we assigned, right, is
Yeah.
myoglobin. This is literally myoglobin on top of my head, on my head top. This is myoglobin from start to finish. Oh my god, I love your face just now. You got it.
Cause that's so cool. Oh my gosh. I didn't realize that before. I always seen you painting and I'm like, oh, okay, he's painting. But I didn't know which structure you were painting. I just know you was like, okay, this is for I don't know. My favorite one is tryptophan. I'll be saying that all the time. This
Yeah.
is color. And I'm like, okay, so he's just assigning colors. But I'm like, it's not my glove floating over his head. This is the painting. So yeah, you got that look just now.
Yes, I love that. I got it. Because that's the thing is like myoglobin, of course, was the first first molecule we got a structure of, right? And so it's really important in the history of things. And so it took me a while to paint this thing because it's a long fucking thing. And so it took me a while. So it starts here with the methionine. The bright pink is the methionine, and you can look at stimulator.com/play. Actually, let me put that in the chat for people who are going to watch later, right? If you go to stimulator.com/play, you see my coloring or annotations that we made in season 3, together with my teaching assistant right here, Camara. And remember, I don't know if you remember writing this up, but you literally wrote up the coloring system that we made with the students, because not only did we link an amino acid to every color, but we also then linked every amino acid to
a song.
To a song off of
Pink Friday 3.
Girl, you gonna get us killed over here, girl. No. You need to let me talk now. Gonna get us taken down, girl. What the hell?
It was a joke.
It was a joke. There we go. Great. Big Friday 2, Nicki Minaj had 25 songs plus one bonus that came off as the FTSU remix, so 26 songs, and we were able to assign every amino acid to a Pink Friday 2 song and every letter in the alphabet to a Pink Friday 2 song, as well as every color to an amino acid. And so
I have a question.
On
the game, when we're painting the sequences, this is basically if you were to take the little maze that's on the game, but to take them and put them horizontally next to each other and squish them, that was how it would look.
Exactly.
Oh.
Exactly. And myoglobin isn't there because it's just a really long. You can see it's a really long protein, and it will take you forever in that game to fill out all the myoglobin. But
more than 1 minute.
Exactly, more than one. I know. The game was really just because I want to get to a point where eventually it's going to be an app, like an app you can download in the store. That's why the VR element. I don't know if you joined in for that conversation today.
Oh no, I didn't make it.
Oh, you didn't make it for the VR. Okay, so that's a separate day. But we have the VR headset here, and we have a company that's actually very interested in working with us. And so we are visualizing these molecules in VR, which means if I can visualize them in VR, I could do Pokemon Go type stuff with now molecules. Okay. You see where we're going? There we go. Yeah. So anyway, so for your purposes, we were able to represent molecules by color, by song, because this essentially also is a playlist, right? I could just play this as a playlist on Station Head. In fact, that's what I did in season 3 and 4. And so, and then in season 5, we went even deeper now, okay? Because it was like, okay, so if we can represent naturally occurring proteins by letters, by colors, by lyrics, what if we take lyrics of songs that we're representing here and turn those into proteins? So now that's the de novo design of it all, right? And so we took a bunch of lyrics from Nicki Minaj, from a bunch of other artists that we had from season 1, okay, that had been made throughout the course of Team Olympics. We also had lyrics lyrics from season 2. There were people who were just dropping lyrics in comments and not knowing what it's about, but doubting the process, just going like, I don't know what this is about. You remember this? I need to reach out to her at some point and be like, this is what it was about, girl.
Mm-hmm.
Takura actually is one of the people who listed some protein molecules as lyrics, and Tammy and a bunch of other people. And so those proteins, together with the Nicki Minaj proteins, sent for lab results. And so now we actually have 2 labs independently verified. So we had a lab here in Boston.
What we did in season 1 and what I was able to present at Abercams in 23 is basically what you're doing now, right? As a collective with all of the lyrics. You're doing what we did with our challenge for the finale with the little lyrics that you find from people, right? And you're
Right. So what you presented was essentially the goals, I guess, of the project. Like, you basically presented the project as a what it could be, right? Because you had made a protein using software that was available, used Protein Generator, and you used your own lyrics to design this protein, and you used basically your knowledge at that point of looking at different structures that we looked at. We looked at hemoglobin. We looked at a couple different other structures online to make sure that your protein looks like an actual protein, even though you're putting in, lyrics that you're putting in. And then we looked at the sequence that you finally had as your output, and we compared that with natural proteins out in the world. And we found, there are actually some that potentially bind to metals, bind to, impurities. And so we started making a theory about what your proteins could potentially be doing, which is, maybe they could, do water purification because they're binding to metals, right? And so your abstract was, your poster was really aspirational, right? It's like where hip hop biochemistry could go. We didn't have a wet lab that we could use to source any of that stuff at that time to actually follow through and make sure that it's concrete, right? Now we do. And so what we're doing now is basically following your exact footsteps. But now we're adding the wet lab component, and now things are validated. So now when we say, hey, this sequence actually could bind to a metal or is thermostable or whatever, it's real. Like, it's an actual molecule now that exists, and this sequence can bind to a metal, which means we can patent it for water purification. It can be in a water bottle that could be sold in the store.
Oh, this is so nice. Okay. I'm being modest. This is great. Okay. Oh yeah.
Yep. And the great thing is, because this has already been a community project from the very beginning, everybody gets a win. Everybody's on the patent. I mean, Nikki's on the patent, okay? Because it's her lyrics. I mean, she on it, Now, Doja ain't gonna make it on the patent, even though you use her beats. She ain't gonna make it on the.
She'll be all right.
Because you used what is it? Get into it, yeah, right? You used get into it, yeah. And I'm gonna put that clip at some point. Get into it, yeah. That was good. That was really good. We're not gonna show it now because we want to make sure Lawyer Lee's stuff is done, okay, before we do anything. And hopefully it's done before November, because I really want to present the stuff, which would be super cool.
And I downloaded it off of, I keep forgetting the name of the app that was on before they dissolved.
Yeah, me too. Yeah, me too. Swell.
I had to remember where I came from, where it started.
Not where I came from. Oh my God, not you being humble now. Oh my God. But yeah, they were really trying to, play in our face about Abercams, because they had talked about sponsoring us for Abercams, and because we had come on there to give them more traffic than they have ever seen in their fucking life. And then talk about, no, that's too much money to sponsor us. Okay, well, best wishes. Couple months later, not there no more.
If they would have had done such
Because imagine if we had taken them to Abercam, if they sponsored us for Abercams, all those people who stopped by our booth, we would have got them to sign on to the Agenki app. You know what I mean?
Mm-hmm.
Which means they would have more users, which means they can advertise to more people, more money to stay afloat. Like,
Yep.
yeah, it is what it is. It is what it is. But so this is where we're at. So neurodivergent lines became proteins. Those proteins have been tested in a Boston lab at Ginkgo Bioworks. They've been tested in a Switzerland lab in Adaptive Bio. They are correspondingly actual protein molecules. They behave like GFP and other natively occurring proteins, and some of them even behave better. They're as thermostable as my thesis molecule that I was showing in VR earlier. So this is grounds of not just hip hop biochemistry being a method of learning protein molecules. Hip hop biochemistry is now a field and discipline for making brand new molecules from scratch. So embedding culture into culture, like literally.
I am very, very proud.
Yeah. So the next step now is our collaboration at Hampton University. These students are literally going to go and take these molecules and take pictures essentially of them. And the final question is, this picture corresponds to what we're seeing in the model, what it was designed for, which is going to be awesome. And I'm going to take the DNA sequence. I'm going to compare the actual sequence. Does it match up to what the lyrics have been saying? Because maybe it's something that is stable because it's actually not what we wrote. Maybe it's a different combination. So we're actually going to take the DNA sequence. They're shipping it actually from Switzerland to Hampton University. I'm going to take it, send it out for sequencing to see, is it actually what we encoded in the proteins that finally.
On the subject, let me type my lyric in the chat because see, I want to play. Hold on.
What is your song? You got to tell me the song and the artist, and then we're gonna play it right now. Actually, yeah.
So I want to submit Fantasia.
Fantasia.
Yeah, be sure you hear me playing her all the time.
Fantasia Barina. Okay, yeah, you used to play her on AMP, did you?
Yes, in the Ice Lounge. Yes, I did.
In the Ice Lounge.
I know. Go sit down and watch TV. Don't open it. Don't open it. So it's gonna be Fantasia. So normally I'll put Lose to Win, but no, it's gonna be When I See You.
Oh, When I See You came up first and then Lose to Win second. So that is so interesting. See?
Yes.
I guess it's one more popular than the other. All right. When I See. And what is the lyric?
The first stanza.
Okay, we can't play too much of it, okay? Because this is YouTube and stuff, okay?
You fast forward it, and then you just go. I put your picture.
Oh, wait, that's it. Hello, Linda. Perfect timing. Perfect timing. Linda is here. Okay, so I put your picture on the mirror. Start to blush when somebody says your name. Is that your lyric?
Yes.
Where does it end? It ends at name?
Yeah, you could do just those two lines. Yep.
Okay, I put your picture on the mirror. Start to blush when somebody says your name. All right, that is in our Gamma data set. Thank you, Kamara. Kamara Ice, aka Damari Morgan, actually presented at Abercamps. Linda presented virtually from Ghana at Abercamps. When did you present, Linda?
2023 or 2024. I've forgotten.
Okay. And so she presented virtually, Stimulator funded that, and Kamara actually presented in person in 2023. And so we want Linda this year to come in person with us at Abercamp. Kamara will be coming too, so you're meeting for the first time.
All right.
Yeah. Kamara, this is Linda. Linda, this is Kamara. You guys will be, we'll be living together in Seattle if everything goes well. Yeah.
All right. Sure.
Maybe you can do a little introduction.
I was saying hi. I just didn't want hers in the background. But hi, nice to meet you.
Nice to meet you too, Kamara.
Linda, maybe you can introduce yourself to both of us as well as the audience, and then we'll do the same with Kamara. Yeah.
Oh, okay. So I'm currently studying epidemiology. I'm in second year. and I have 4 years experience in biomedical research, which I got in Ghana, and also I'm working with Dr. Daku here in the US at the University of Health Science, Texas, and we are focusing on microbiology. Yeah.
Yeah, how's
Mm.
that going, Linda? It was a long journey for you to come to America. How's that going? Congratulations,
Yeah.
you made it. Yeah.
Thank you. Thank
How
you
is
very
that going?
much.
Yeah.
It's okay. Texas weather is just like Ghana, so yeah, it's okay.
Oh, the weather is like Ghana, is it? Okay.
Yeah, yeah.
Where in Texas are you?
Houston.
Hmm.
Yeah.
Okay, all right, that's great. That is great. Okay, so you said it's just like Ghana actually in terms of weather. That's good. That's really good. Yeah, and school is going good. This is your second year, you said?
Mm-hmm,
The
mm-hmm.
PhD
Yeah.
program?
No, masters and then I'll pursue to PhD. Mm.
Oh, master's. So it's a 2 year program, 2 year masters.
Yeah, 2 years. Yes.
Oh, nice. So when do you graduate?
Next summer.
Next year, 2028. Oh,
No,
2027. Sorry. 2027.
yes, yeah, 2027. Yeah.
So if you started to apply for grad school?
Yes.
Okay.
Same school. I'll continue in the same school in the same program.
Oh, you're continuing at the same school, saying it's part and parcel of the program. Okay, okay.
Yes, yes,
It's you got funding?
yes,
Oh, it's fully funded. No, no,
yes, yes,
no,
yes.
no tuition. You don't have to worry about that. That's good.
So you have to, with the master's program, you have to, let's say, get a GRE position to be in state, so your fees will be lesser.
Mm.
So that's their kind of scholarship. But with the PhD program, it's fully funded.
Okay, that's good. That's amazing. That's congratulations, Linda. That's great.
Thank
And so
you. Thank
hopefully you
you.
can get some more scholarships at Abercamps, okay? Get some book
Oh,
money scholarships on the side. Also explore some other schools. They might have programs that are comparable to what you have at Texas, right? And then maybe after you get your master's, you can switch. Because who knows, if you
okay.
get a position at Yale, are you going to stay at Texas?
No.
And Yale University will be there, Harvard will be there, all these schools will be there. So it's a good opportunity to come in person, talk to the recruiters, talk to faculty. And even if you don't leave, these are good opportunities to collaborate with people from those universities. So some of your papers, your research papers that come up in the future could potentially be based on projects that you collaborate with people you meet at Abercamps, which would be very good for you. So
Okay.
all right. So what Kamran Ice is going to be presenting is essentially the simulator work that we've been doing on hip hop biochemistry for the last few years. Do you want to present your work currently now at Texas? Do you think you'll have approval to do that?
No.
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 Okay, that's fine.
Mm.
That is fine. You can present our research, but you will still have to submit though through your Texas account, because you have to be a registered student to be able to
Okay.
participate in Abercamps. So you can present some of the research that we're doing on here, and so we can kind of iron out which side and which side. I think Kamara has a depth of about the research to play with, right? And so I think we can also delve into some of like the structural biology of it on your poster, right? We can take a look at some of the folds that came out. So we basically made proteins out of hip hop lyrics, and these proteins we tested them in the wet lab. 2 independent labs here in Boston as well as Switzerland have confirmed that these are proteins. They're actual proteins. They behave as good or better than naturally occurring GFP. And so this is amazing. And so the DNA is actually being sent to Hampton University, who we're collaborating with, and they'll do some CD circular dichroism experiments as well as X-ray crystallography to take pictures to actually figure out do these molecules look the way they were designed to look. And so that is going to be super awesome. And so I think a focus for your abstract could be these molecules that were not designed with anything, in terms of naturally occurring molecule shape in mind. What do they look like? What are they predicted to look like versus what do they actually look like? The predicted structure, what if you compare it with other molecules, native molecules, do they group into families? We kind of did a little bit of this already, so we kind of have an idea of the answer. So you can present that portion as well, which is be good. And so you'll get some answers and some questions. And you signed up for one of the seasons, right? What season did you sign up for? Oh, I think you're on mute.
I think 15, season 15. Can you hear me? Hello?
No, we don't have 15 seasons. I wish I wish we had 15
Uh,
seasons.
I think
We don't have 15 seasons.
I didn't qualify, so I just put in the protein, but I didn't get the color code for it. So you were asking me to color it, or but I had
Oh,
exam.
so it was this season, this last season, season 5.
Okay, yeah, season 5. Yeah. Season 5.
Because you went to this website, right? And then you were coloring different proteins, right?
Yes. I was able to identify the, I think, amino acids, but you asked me to color them, which I had like exams like an hour two. So I just had to pause and like, okay, next time I'll join season 6, the following season. Yeah.
Yeah. Okay, all right.
Mm.
Well, take a look at Abacam's website, sign up with your student account. Once you
Okay.
create an account, send me your login details, and we'll figure out the registration for you on our end. And then later on, we'll submit the abstract. Does that sound good?
Sure. Yeah.
All right. Well, thank you so much, Linda. Yeah, do you have any questions or anything?
No, I'm okay. Yeah.
Yeah. All right. Thank you for coming on. Appreciate you again. We'll talk soon.
You're
Yeah.
welcome. All right, sure. Take care. Bye
See
bye.
you on the WhatsApp. And
All
see
right.
Kamara soon. You'll see each other very soon in person.
All right. Bye.
All right. So Kamara, yeah. I think you got you've got. Oh, what happened? Oh.
I was closing the door.
Oh. Okay. Let the babies talk. I'm always like, let the babies
They
talk. Y'all
they
never
not
let the
talking.
babies talk on amp, huh?
They not talking. They complaining. That's what they're doing. I don't want to hear all that. I don't want to say this and be all like, what?
That is hilarious. Oh my god, that is so funny. Yeah. No, it's fine. It's fine. Um. All right. So yeah, we need to get your abstract ready and everything. So we'll start working on that. Next time you'll be available for live. Let's go ahead and submit. I think submission deadline is the 1st of September. So
Okay. Kids go to school Thursday. I should have some free time in the early afternoon or morning after I drop them off. And then I don't know how I'm going to look after that. But I know for a fact Thursday I am off. So we could play around on Thursday and get me a little more comfortable with what I remember and what I need to have ready.
okay.
And then yeah, we could submit. I'll make I'll register my email today for the the registration for Abercams.
Yes, please do that, and then shoot me the login details. We'll get that covered for registration when we submit, so that
Okay.
do a big one, and then I think we'll find out about the hip hop thing later. I have no idea, but until we find out, we cannot make any plans about that. Because yeah, if I'm not presenting, I'm not going. So
Yeah, I off, but let me know.
What you say?
I said, well, yeah, they need to hurry and let us know. I took that little Saturday off. It's only one day, so it's not really a big deal. But they need to let us know.
Yeah, very soon. We gotta know. We gotta find out. And I mean, yeah, I guess if we're not presenting, we can still go, just to see what it's about. Because I've never been to such a conference, a hip hop conference. I've never been to that.
Yeah.
No idea what to expect. I think it's gonna be good. They're gonna be. I don't know. We have Nikki all throughout the abstract, so because I ain't hiding it, okay? Because it's definitely influenced by Nikki. Like I'm not hiding that. And so
Sparked a little bit of interest. Like, what they doing over here with Nikki? Hold on.
I don't know. We'll see, because it's a different sentiment all across the board. Like people have different feelings. Like I was in a whole argument yesterday with my cousin about it. So people have different feelings, especially with this new direction she's gone. So I mean, regardless, okay,
Music
did
is
the research.
people are people. It's a slight difference. It's a thin line that we can't merge. So music is music, and we can't knock the music. So
No, but I'm saying we're gonna present her anyway, because that's the research we did. We did it with her lyrics, so I don't care. Like just people are gonna feel the way they're gonna feel, but we can't do nothing about that. Like that is this is the research. These are the molecules. So when she says she did her research, now y'all believe her. She's actually doing research. All right, Kamara. Well, we'll talk very soon. I'm going to sign off soon because I am exhausted. I've been on live for the whole day. Do you hear me? The
Oh,
whole day.
yeah. Okay, cool beans.
Yeah. And by the way, that molecule, we need to get you one of these. We need to get you
Yeah,
one of these.
yeah. I want
Very soon.
one, a 3D printed one. Yes.
Yeah. So start thinking also of your protein that you would like. So, 'cause, we'll get you one of these and we'll get you like a 3D print. Think about that. Of course, your protein, of course, will get you a 3D print. But
Yeah,
you
but I
should
want a nice, cute one. I want to paint my own now because now that I know what this is gonna be, now that I know and I see the finish, I want one around the border of. Find me a long one, and I could have a fun hobby painting it, and then I could. Yeah, yeah.
it's really, it looks simple. It's not. Because remember, you have a specific order to go. If
Mm-hmm.
you mess up, it's no longer scientifically correct. So
Right.
you have to start over.
It's
And
also so I like that.
yeah. And then what I was doing was I was putting tape
I
on
remember.
so
I
that
remember.
it's correct. And oh, that is annoying. It gets a lot. But I'm gonna be painting some more too because I'm gonna see if I can try to exhibit this artwork. So if you make one, we can both exhibit. In North Carolina, there's a exhibit that's ran by somebody. We could try to.
So like you're my teacher, so you might as well assign me one. And
No, you should pick a protein. Just pick. Let's see. Let's see. I mean, you should pick one that is manageable, not too long.
mhm.
But I almost don't want to give you the one I want to do that is manageable. Because I want to do it.
I don't know. It's a million and thousands and millions and the 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 millions.
Yeah. Okay. Do insulin.
Insulin. Okay. It's chosen. I shall do it.
Yeah, make sure to confirm the sequence with me before you do it. Go find the sequence and then confirm it with me. Make sure before you start doing all that work that it's accurate.
Yeah. Okay. I can
And
take
there's a special thing in there in insulin that I don't know how you're gonna figure out, but I don't think because this one didn't have any disulfides. Yeah, because there's no cysteine. No, yeah, there's no cysteine in here, so there are no disulfides in myoglobin. You are going to encounter quite a few disulfides, and so I don't know how you're going to represent that. And so that is something to think about. So the structure of insulin though is out, and then the sequence is out as well. So take a look and yeah, think about it. We can represent it in VR too at some point, and then we'll get you a model of your insulin. Yeah, once you once you put in some work, and then we know you're serious, then we'll get you a 3D printed model of insulin.
Okay.
And you know what insulin is, right?
Yes.
What is it?
Why are you doing that? Insulin is produced by the body, so it's the protein that's produced to. Oh my God, the pancreas produces it to
Yeah.
manage the sugar in our body, and I'm gonna just say distribute it where it needs to go, and then tell it to leave when it needs to leave through.
That's true. That is true. Yeah. It converts glucose to glucagon. And sometimes reverse, I think. So it allows sugar to be stored for later on and converted into non-toxic stuff. Convert glucose into non-toxic. Yeah. So, all right, Kamal, thank you so much for coming on in. I really almost want to play the song again because I'm so obsessed with it right now.
Exactly. Good.
Isn't it good? It's so good. That's made by AI in 5 minutes. That's crazy. But I mean, if you know what you like, you already know.
I hope somewhere down the line, someone is finding a way to increase the water that is being drank by all of the AI. That is
Yeah, well, okay. All right. Good luck with that. Yeah, but hey, AI is gonna figure that out. Okay, AI is gonna figure out the water shortage problem. Okay, and that's all. Period. I'm excited about this EP. It's coming out very soon.
Remember when Gail King was talking to the AI lady and she said, "But Zaina, girl, you can't sing."
It started with a wheel carved out of stone. The circle of progress, the first seed sown. We spun the earth before we knew its name. Chasing horizons, sparking the flame. From the fire to the forest to the print to the word. Every whisper of progress was a scream unheard, but not a hum of wise. It drowns the air. A new dominion, a digital snare. Technology rules the world, it wears the crown. From the heavens above to the underground.
Okay. That's technology.
That sounds literally like the brother of Science Rules the World Around.
Yes, and it is. That's the second song on the EP. So his first song is Science Rules the World. Second song is Technology Rules the World. Third song is
I hope you're not gonna say proteins.
No, Engineering Rules the World. Don't you see what I'm doing?
On STEAM.
Technology asked how. Engineering grabbed the wrench, said, watch me now! Blueprint to backbone, stress test the load. Mechanical muscles, electrical codes. Chemical reactions, civil roads. Aerospace dreams, leaving gravity mode. Measured in microns, miles, and time. From bridges that hold to chips that shine. When theory stalls at the edge of doubt. Engineering builds the way out. Every system needs a pivot. Every future needs a turn. And find the fulcrum, shift the weight. That's how lessons get learned. Engineering rules the world. Who rules? Engineers. From code to concrete, steel to pearl. Who builds? Engineers. Science sparked it. Tech scaled it, widened, scaled it. Engineering made it real. Say it again.
Okay.
You're not you teacher. Oh my gosh. This is I wish this was in school. This is a lesson in the song. And then you have to listen to the words. This is gonna be in school. Like they're gonna take your song and teach the kids.
And here's the part that is gonna blow your mind just now. I don't know if you have connected. Everything you're hearing is a molecule.
Mm-hmm.
No, do you understand?
Yeah, because technically every letter is assigned the amino acids. Are you talking about?
Like literally, I have turned every phrase that I wrote for this music for this EP into a protein molecule.
Oh, so you already submitted your lyrics like you're doing for everything else, and I'm listening to your molecule that you made. I'm listening to science. This is cool.
Okay, so engineering. Next one, what do you think it's called?
Art.
Yeah, art rules the world, and it's a little bit different.
They say you make art now.
Also, by the way, I don't know if you noticed, Science Rules the World is a kid, right?
Mm-hmm.
Technology Rules the World is like the brother, as you said, right? Still kind of a kid. Science Rules the World, I would say toddler. Technology Rules the World, I'd say probably like 10, 11. Engineering, like teen. Technology is teen. Engineering Rules the World, you heard it was more of like an adult, really, like college student age. And now you're hearing the voice of Art Rules the World. This is a man, okay?
But tell me,
and a woman.
Who did you learn that from?
From everything you left behind.
I bled on these canvases, paid my dues, start for the vision, set my blues, now my style's in your data set. No consent, no name, no credit check. You remix pain you never felt. Call it prompted, I call it dealt. You moving fast, I'm losing ground. Tell me, where was I when you got found?
I don't steal, I synthesize patterns, echoes, average lines. I don't feel hunger, fear, or pride. I mirror what the world supplied. I mirror what the world supplied. You train me every post, every share, every brush stroke left in the air. If I'm guilty, then so's the crowd that fed the machine and called it loud. Who owns the earth? Who owns the spark? If I'm a ray, who is the mark? Art rules the world. Who made humans? Art rules the world. Who scales missionless?
But without the soul, without the voice,
there's no meaning in the noise.
this. Oh my, this whole project. You smart. Okay. Smart.
Thank you.
Smart. I admire the creativity because you be thinking about stuff and me, I'll be like, oh, what he thinking? You be thinking and planning and be like, okay, we're gonna do this a little bit. And y'all don't know what it's for, but we're gonna do this.
All right, last one. Well, last two. What do you think it's called? The next one?
Mechanics.
No, girl. What the M stand for? I'm gonna tell Natalie. You both don't know what the M stands for.
No, you know what? You know my relationship with mathematics. Okay. You know
well, actually, that's what the song is about. It's So yeah.
Okay.
A grown man now. Grown man.
You showed up clean, no room for doubt. Every answer figured out. You traced my dreams in rigid lines. Turn my chaos into signs. You don't bend, you don't forgive. You tell me how I'm supposed to live. Every feeling overruled by the logic you impose. You call it truth when I feel small. You call it proof when I fall. You never ask me how I feel. You just decide what's real. Math rules the world, I feel it by cold equations, sleepless nights. You weigh my worth, you draw the line. Say love must fit a defined design. And you never bleed, you never break, you never risk a wrong mistake. Math rules the world, always win. And I'm tired of losing to your queen.
All right.
He done got grown.
Grown. Talking some grown
He
stuff.
knows what.
No, but Kamara, you have to help me because I want to do like a 24-hour marathon with like different DJs on Station Head and like just go from one, to the other where they basically listen to the whole album and review it, like with whatever audience that they have in there. Like, so you got to help me. You, Tia, like I started the conversation with Tia and somebody she put in a group chat for last time when so I was going to release it on the 1st of May, but then the lab results were not ready yet. And so then, we submitted for the lab results and now they're ready. You know what I mean? So it's coming out and I got some people who actually are going to be remixing some of the songs. So.
Ooh, I have somebody in mind who I want to hear on the last track, but go ahead.
Oh, really? Oh, wow. On the last one? This one?
Yeah, because his voice mimics the last one. Yep.
Really? Huh? Somebody I know?
Yep.
Who?
I don't know his name. Hefe?
Oh, that is so funny. That is so funny that you said that. That is so funny that you said that. And we're going to leave it there. We're going to leave that there. It's so funny. Love how you think. Okay. But yeah, no, we need to talk about doing the marathon, Kamara, because I need you to reach out to folks and we need to get, Capricorn. We need to get people to just do just 1 hour, even 30 minutes, because this album is only 6 songs. So it's not that long,
Okay, yeah. I'm for sure.
Because then I basically want to record the music video for it. Like where, it's like just a screen record of station after station after, you know what I mean? Like that is kind of awesome. I wanted to do it with AMP, but yeah.
I'm still waiting for them to bring up some new development that we were waiting on. So that's not the we still in limbo, but okay.
Yeah, I guess it's Twitch. Yeah, that's where it's at. I guess. Yeah. All right, and then it all ends in, of course.
From Zimbabwe's breadbasket, ancient dreams arise. Egypt's pyramids, where knowledge never dies. Burn that boy's fire, tell me soulful beam. From Africa's art, we launch our steam. Liberia's promise, freedom's first light. Then we cross the Atlantic, America's in sight. From Hefe and Hebe to Nick and Kali M.
Okay, all right.
stop it right where you stopped it last time.
I'll go to the end again, and then you need to sign off. We need to go, Camara. Okay. All right. See you later. Oh, well, that's too far. No science and tall wherever we go. Steam rules the world, and I will not see you later. I will see you later. All right, Camara. I won't see you later. I will. Steam you later. Bye.